So here I was actually trying to figure out how to demonstrate the distances we're going to be discussing today, because it's super far. And I came up with this. So essentially here we're flying at approximately 100,000 light years per second. As you can see, our galaxy is slowly disappearing into the distance. Now this is really fast. And not just fast, but potentially physically impossible. But even though the galaxy is already over 1 million light years away from us, we're going to be flying this way to our current location for a pretty long time. If I was basically making this into a stream, trying to record this in real time, it would probably take, I think, about a week or so of real live streaming. Let's maybe accelerate a little bit, just to move a little bit faster. And so we're going to a location described by the redshift of 6.2. This is when the universe was only about 900 million years old, or in terms of physical distance, approximately 28 billion light years away. That's pretty far. Right now we've covered approximately 1% of that distance, and the object we're discussing is located in a galaxy far, far away. The object you see right here, Earendel, the farthest star ever found. And so just the fact that scientists were able to discover an individual star at such a ridiculous distance kind of shows us the power of modern telescopes. Just imagining this sort of blows my mind. And so, hello wonderful person, this is Anton, and today we're going to be discussing some of the recent updates and some of the recent discoveries, both in regards to this particular star and also in regards to the galaxy where it's located and some of the other objects that seem to be close to it. Because we have at least 2 papers where a team of scientists was able to figure out, first, the color of the star, determining exactly what type of an object this is, but also uncovering a few more things about the galaxy where it's located. The galaxy, that because of its shape, is now known as the Sunrise Arc, the most highly magnified galaxy ever discovered in the early universe. And so let's start with the star itself. Now, relatively recently, we've actually discussed a slightly different, slightly closer star that scientists now refer to as Mothra, which today scientists believe might be a completely new type of a star. You can learn more about why in that video in the description. But Earendel does not seem to be the same. As a matter of fact, it doesn't seem to belong to types of stars that we now refer to as kaiju, with the star known as Godzilla being the most famous. These stars are just ridiculously bright. In this case, it's about several million times brighter than our Sun, which is one of the reasons we're able to see them as individual objects at such faraway distances. But the main reason they're visible at these distances is of course because of very powerful gravitational lensing effects from really massive galactic clusters that seem to be located between the star and planet Earth. As it usually happens with gravitational lenses, this completely accidental arrangement produces various lensing effects that can then magnify the light by anywhere from several hundred to even several thousand times, in essence allowing us to see some of the most distant objects out there. And so far, all of these individual stars were essentially discovered in this way. And originally, the star known as Earendel was first seen by the Hubble telescope and discovered once again completely by accident. But it was still a little bit unclear if this is actually an individual star, a collection of stars, or possibly some kind of a globular cluster. As a matter of fact, you can actually see in the image there are several similar objects in this arc. But in terms of gravitational lensing, this example is one of the most extreme cases of magnification through gravitational lensing. Here, things are magnified by about 4,000 times, with some parts possibly even magnified up to 40,000 times, with the star being one of these extremely magnified objects. But Hubble was not enough. It took observations from the James Webb Space Telescope to finally confirm a lot of things scientists were hoping for. First of all, this is definitely an individual object, as in it's not a globular cluster and not a collection of stars or some kind of a baby star nursery with many different bright objects. Just to give you a comparison, here's what the Hubble image looked like, and this is of course the one from the James Webb. And it's absolutely mind-blowing what the James Webb was able to achieve here. It was able to definitively determine that all of this light is coming from a really small volume of space, no more than about 4,000 astronomical units, basically just a fraction of a light year. Which of course means that it's not a cluster of any sorts, not any large object, and has to be a star or possibly a binary system, maybe triple system, with a central bright star in the middle. But more specifically, it was able to even do spectroscopy determining the color of the star. It might be easier to understand if we look at this stellar classification chart. Our Sun is the G-type. This star is the B-type, a blue giant approximately 13,000 to maybe 16,000 Kelvin in temperature, and possibly up to about 1,000,000 times more luminous than the Sun. Very similar to other B-type stars that we have right here in the Milky Way, stars like Regulus that you see behind me, and Algol. Stars that have a tendency to have a lot of solar wind, with velocities up to 3,000 kilometers per second, very often spin really fast, and often exist for just a few million years. Pretty much all of these stars eventually go supernova, with many of them then leaving behind a neutron star or a black hole. In this case, based on the mass assumption of about 50 to maybe 100 solar masses, it's probably going to leave behind a black hole. But a lot of these B-type stars very often have a partner. Regulus does, so does Algol. These stars are very unlikely to be solo. And here as well, based on the colors of Earendel, there are some hints of some kind of a cooler, redder companion star. So this is probably some kind of a binary at least. But it would be impossible to resolve this at this point. Once again, it's just super far. But one of the bigger questions in this case was, could this be one of the first stars in the universe? Could this be population 3 star? A star only containing hydrogen and helium? Well, based on the preliminary observations, the analysis of temperature, and the fact that this is a B-type star, it doesn't look that way. It just looks like a young star forming somewhere in a galaxy, in a young galaxy that's still developing as well. But the other question was, what exactly are those other spots? Is this maybe a gravitational lens from the same star, or is it something entirely different? Is it basically more very bright stars? Turns out that it's not. These are not stars at all. The other dots are very small clusters of stars, with some as small as just 10 light years across. And intriguingly, all of them very young, less than 5 million years old. So these are actually slightly older clusters, possibly about 10 million years old, but not globular clusters yet. Here the suggestion is that they might become one, or they might just create a bunch of stars, dissipating in the process. And today one of the bigger mysteries in astronomy is trying to figure out how various globular clusters formed in the last few billions of years. Although actually the bigger mystery is why exactly they no longer form anywhere. Without exceptions, all globular clusters in the galaxy are about the same age and have stopped producing new stars a long time ago. And so the observations from this region do have a chance of potentially answering these questions. But no answer yet. And in total, it looks like there are at least 6 different clusters here, with around the same age, actively forming stars, basically suggesting that this is a relatively brand new galaxy that's going through rapid development. Now this is in the first 1 billion years of the universe, so it does make sense. But it's of course the star itself that's essentially the most incredible discovery in this particular region. It's quite unlikely that we're going to find anything farther for a very long time, or at least not until we find new gravitational lenses with even more magnification power. Although, as you might have learned from the video about the other star, Mothra, sometimes scientists get lucky and a chunk of something really massive, potentially dark matter, seems to magnify certain stars even more. And so yeah, the night is still young. We might find something else. Although when it comes to gravitational lensing and really distant stars, apparently James Webb so far has been absolutely incredible. There is another recent study that discovered 2 more stars at very far away distances, although here the redshift was about 4.8, so these were slightly closer. But anyway, it means that we're going to be discovering more of these objects for many years to come, as long as James Webb provides more data. With the absolute ultimate discovery that everyone is hoping for being an image of a distant star that happens to be what's known as a population 3 star, the first star in the entire universe. Hello wonderful person, this is Anton, and today we're going to be starting with this. The image of what we're actually talking about, because by itself this is the definition of clickbait. And except that this is a real image taken by the scientists a few years ago. And you can learn a little bit more about this in the article from 2020, where essentially the scientists talk about the discovery of this very distant galaxy SPT 0418-47, seen as this circular feature. And you might have already guessed that this is actually an Einstein ring. A phenomenon of gravitational lensing that usually happens when there is a really massive object aligned with something else behind it in a very specific way where it actually produces an almost perfect circle. A circle like this. But in this case, it then becomes possible to kind of create a reconstructed object by trying to figure out where all of this light came from. And following this reconstruction, the scientists discovered something somewhat unusual about this galaxy. Well, first of all, it's kind of far away. It seems to have existed when the universe was only 1.4 billion years old, But second of all, it seems to contain a lot of Milky Way-like features. So basically features expected from a galaxy that's much older, and features from a galaxy containing some kind of a galactic disk. And so despite the image being really cool, even the discovery itself was very unusual and extremely exciting. But this is of course back in 2020, and actually originally discovered using the Chile's ALMA telescope, which observed it in the microwave frequencies. So in essence, this is just showing us the gas within the galaxy, not really the stars, and not the interaction between the gas either. But now the same object was observed by the iconic James Webb, and the scientists discovered something else that was even more surprising. Something that was previously unseen by other telescopes, and something that could only be detected with infrared observations. There seemed to be something else right next to it, and it also seemed to be extremely unusual in terms of chemical composition, and even in terms of the evolutionary stage and activity, presenting yet another mystery coming from the James Webb that at the moment has no good resolution, and possibly once again one of the bigger mysteries out there. But here it's also important to understand what we already discovered from some of the previous studies about this unusual object. And specifically it was when the shape itself was reconstructed, and when the scientists were able to measure minute deviations in redshifts and blue shifts. The first discovery here was that, strangely enough, this galaxy was not particularly chaotic. As in, it didn't really have a lot of material moving really fast around, and it seemed to be much calmer, as if it was already quite developed. The redshift observations have also discovered that there's definitely some kind of a galactic disk. There was even a very large concentration of stars packed extremely tightly near the galactic center, which would be the first time ever that the galactic bulge in any other distant galaxy was definitively confirmed. A lot of these features usually indicate that the galaxy has already been developed quite well, and normally this is kind of something we expect from the galaxies very close to us, such as the Andromeda or even the Milky Way itself. And so the fact that this galaxy was already quite calm and quite well developed 1.4 billion years after the formation of the universe was a little bit unusual. Not impossible, just very strange. But because none of this involved any chemical observations, and even the mass and the size of the galaxy was unknown, back then none of this was too surprising. It was, like I said, unusual, strange, but not super surprising. With all of this sort of changing, once the James Webb Space Telescope was able to observe this galaxy as well. And by the way, it very likely does not look like this is just a simulation. And after a few months of analysis, the scientists were able to finally reveal their findings in the paper you can find in the description. In a nutshell, here's the main finding. This galaxy has a partner, a somewhat difficult to see partner that's invisible in this image. But the partner that becomes a little bit more obvious once you observe this with the infrared frequencies. There seems to be a smaller companion galaxy that was previously hidden behind the light of the galaxy creating the Einstein ring. It's approximately 16 times fainter than the bigger galaxy, but seems to be about 16,000 light years away from the center of the bigger partner. Implying, of course, that this is an example of interacting, very likely colliding galaxies, but in this case a much bigger galaxy with a much smaller one, possibly producing very similar effects to what we see around us in galaxies that usually have very long tidal tails and galaxies like the tadpole that you see right here. This is very often caused by a smaller partner, but the actual surprise came from the chemical analysis. Turns out that this smaller partner galaxy, that once again as a reminder is supposed to be really old, had an extremely high amount of relatively heavy elements. In other words, it was very high in metallicity and was very enriched in various chemicals, with the overall metallicity being extremely similar to our Sun, which is very high in metallicity, implying that this particular galaxy was actually a host to a lot of very old stars, multiple generation stars, that very likely were created as a result of many different supernovae happening in a surprisingly short period of time, enriching all of these stars in possibly just 1 billion years. Something that would take a galaxy like the Milky Way at least 13 billion years. And just to confirm that this was actually coming from a partner galaxy, the scientists in this case compared the redshifts detected from several different signals, confirming that two different sources in the image were definitely at the same distance, located at a redshift of about 4, so when the universe was 1.4 billion years old, confirming the existence of not just hydrogen, but also nitrogen, sulfur, and ionized carbon in relatively large amounts, similar to a much older galaxy. But also suggesting that this is probably just two galaxies inside a much more massive halo of a very large cluster, possibly galaxies interacting and colliding, but with what seems to be extreme frequency and extreme efficiency, dramatically enriching the galaxy's metallicity and somehow allowing it to be very similar to our Sun a star that formed at least 8 billion years after. And somehow in this galaxy that's only 1.4 billion years old, we already have very similar composition and very similar metallicity. And though it doesn't really break all of the theories of star formation and galaxy formation, it definitely adds a major constraint. A major problem for modern cosmology that's not going to be very easy to solve. But definitely not the first problem coming out of James Webb in the last few months. And quite a few videos in the description below tackle some of these problems in more detail. And based on what we know about our Sun and how the Sun acquired its metallicity levels, today the modern theories suggest that it probably involved at least 40 separate supernovae with the material recycled over and over and over again before it became enriched enough to form the gas filled with materials that were not just hydrogen and helium and filled with a lot of other stuff that would eventually result in more complex chemicals and even allowing objects like planets to eventually form. Especially terrestrial planets, which are predominantly very high metallicity and contain a lot of stuff that's not hydrogen and helium. But in this galaxy that's only 1.4 billion years old, it would just be very difficult to explain why so many supernovae would happen here as well, enriching everything to the same degree. But obviously there are at least a couple of possible explanations that come to mind right away. One of them is from a very recent discovery that should be in the description of a very unusual object that was recently discovered that essentially contains some kind of a very massive black hole covered by extreme amount of gas with a ridiculous amount of activity. A galaxy that's basically evolving super fast. This object was only seen completely by accident and is actually only visible in very certain frequencies using microwaves, invisible in every other frequency. And it seems to be able to explain at least the existence of some of these very well developed galaxies and kind of points at our misunderstanding of galactic evolution. It looks like early on, a lot of early galaxies just evolved very differently from what we believe and from what we've been able to simulate or from what the scientists can even see around us. So this is maybe one explanation. The other explanation is, of course, well, we're looking at the gravitational ring here, which means that there's still a chance that maybe some of these observations may have potentially been misinterpreted at least to some extent. Especially because in this case, the shape of the galaxy had to be reconstructed, and we're talking about objects at really super far away distances. And so for all we know, maybe there were some detections coming from certain regions of this galaxy, showing us that those elements already existed, but because the image itself is very stretched and quite deformed, we're just seeing a kind of a bias here that sort of shows us that there is a lot of metallicity, but in reality we could be just looking at one chunk of the galaxy, like for example some kind of a globular cluster that just happens to be very high in metallicity, whereas everything else is not. So once again, it could be some kind of an observational error. Nevertheless, it's still a really exciting discovery and also a really beautiful picture that I'm really hoping to come back to in some of the future videos, because this is a pretty interesting mystery and something that at the moment does not really have a very good explanation. Okay, maybe one explanation. Maybe the current understanding of galactic evolution and the formation of stars in these galaxies is just very primitive, and when the scientists try to simulate this using supercomputers, it always just lacks something really important that we don't really realize. In other words, maybe the computer simulations are just not the best way to try to explain what actually happened in the early universe. And it's really the objects like this that was just discovered a few months ago that might help us answer all of these questions much better. There's this one mystery in astronomy that's still unresolved even today. The mystery in regards to extremely massive black holes. Black holes that are usually way more massive than anything known to us, and black holes whose mass is extremely difficult to explain if these objects were growing as we expect them to grow over time. And in the last few years, quite a few of these black holes have been discovered, but more importantly, in the last year of the James Webb Space Telescope observations, quite a few of these unusual objects have already been discovered in the extremely early universe, when the universe was under 500 million years old. And because many of them have masses usually much higher than the one in the Milky Way galaxy, explaining them once again became a little bit difficult, but not impossible. There are two major explanations. One of them essentially involves these population 3 stars, or first stars in the universe, and you can actually learn more about this in one of the videos in the description, that would collect so much early hydrogen and grow so massive that eventually they would just collapse into relatively massive black holes, possibly hundreds or even thousands of solar masses in mass. And then by joining together with other gas and other similar black holes, they might grow into black holes that would be millions of solar masses. But this so-called sequential process fails to explain something else. It actually fails to explain some of the earliest quasars that have been so far discovered by the James Webb and by a lot of other telescopes. And because quasars are some of the most luminous or most bright objects in the entire universe, seeing them at extremely far away distances does actually create a bit of an issue. According to previous propositions, quasars would most likely be created around the time when the universe was about 1 billion years old, would stay very active for a couple of billion years, and would then slowly disappear, turning into more quiet galaxies. But discovering quasars in a universe that was less than 1 billion years old did create a bit of a problem for these earlier explanations and even earlier propositions in regards to the growth of these massive black holes. A bunch of population 3 stars collapsing into these black hole seeds would still not really explain how something can form only 500 to 600 million years after the formation of the universe. And so this new recent discovery coming out of James Webb, along with the Chandra X-ray telescope, present us with a really exciting and interesting case. A galaxy now known as UHZ-1. This was a lens galaxy in front of a galactic cluster about 2744. There were 11 galaxies discovered here, but only one of them was visible with the X-rays. And as you can see from this particular observation from the James Webb, it's at a redshift of 10.3. Basically, the universe here was 470 million years old. And because it was producing X-rays, it became possible to analyze it using Chandra X-ray Observatory as well. And if a bright galaxy produces X-rays, the only source can be a central black hole that produces what's known as AGN, active galactic nucleus. And further analysis established this to be a really odd quasar. Now, first of all, based on the amount of X-rays coming from here, it became possible to determine its mass, the mass of the black hole and the mass of the galaxy. It looks like the central black hole is about 40 million solar masses, 10 times as massive as the one in the middle of the Milky Way. Not the biggest, but definitely not the smallest. But by existing so early in the universe, it was very difficult to explain its formation. But not impossible, because there is a second explanation to how massive black holes can form in the early universe or just in general. And it's actually a model that was originally proposed a couple of years ago, and you can read more about in a paper in the description. Unraveling obese black holes in the first galaxies. There were quite a few scientists involved here, but Agarwal Bhaskar was the main researcher. And the explanation here uses a very intriguing analysis by basically trying to imagine what the early universe might have been like and what sort of radiation there was here. Because of huge amounts of different types of radiation, certain types of gas would instead collapse directly into much more massive compact object, potentially producing what the scientists refer to as direct collapse black holes, DCBH. With the original paper predicted them to exist specifically at this period of time when the universe was between 350 and 550 million years old. More importantly, it predicts them to be super bright, very likely most luminous objects in that part of the universe, much brighter than any galaxy nearby, and even much brighter than the collection of all stars in the middle of this galaxy, with scientists coining a term OBG, obese black hole galaxies, as a kind of a new class of galaxies we never knew existed, and something that no longer exists either. Something that's defined by one simple fact. The black holes here are usually more massive than the rest of the galaxy. Or basically, the mass of the central black hole is a lot higher than any gas or any stars. At least initially. Over time though, because of collisions, the galaxy changes a little bit and becomes a regular quasar, eventually becoming a regular galaxy. And the scientists in the paper even make predictions for how we can find them, where we can find them, and what they might resemble if we do find them. Turns out they were actually right, because that's exactly what the scientists just discovered using this new study. Or technically 3 separate studies, that as always you can find in the description below. And all 3 studies are discussing the same object. It's now referred to as UHZ-1, a very distant, very bright quasar, whose mass is quite dramatic compared to any other quasar. As I mentioned, the black hole mass is about 40 million solar masses. But the galaxy where it's located has a total mass of 140 million solar masses. It's a dwarf galaxy. So basically a huge part of this galaxy is the black hole. All of the other previously discovered quasars do not have these mass proportions. Here it's usually about 0.1%, not 28% like in the case of UHZ-1. And even though initially it was kind of difficult to explain this, it looks like that prediction from a few years ago is spot on. Meaning that this black hole must have grown really quickly, because huge amounts of molecular hydrogen prevented star formation and allowed for this gas to then collapse, forming a really massive object in the middle. And not just a massive object, extremely bright object, brighter than the galaxy itself. And because population 3 stars or any other type of a collapse does not do a good job explaining the existence of this object, right now this study right here seems to be directly validated by this new discovery. Although one of the propositions here is that once the black hole forms, it potentially collides and absorbs stars and gas from some sort of a nearby galaxy, forming very close, with the resulting OBG or obese black hole galaxy being a combination of a massive black hole combined with a smaller galaxy whose stars and gas then start orbiting around the center. But because this requires hydrogen that's not ionized, hydrogen that existed in large amounts in the early universe, it would be practically impossible to create something like this after a few 100 million years once the universe ionizes everything, during a period we refer to as ionization, when the entire universe suddenly became somewhat transparent, replacing molecular hydrogen with ionized hydrogen. So definitely a super important discovery coming out of James Webb and Chandra X-ray Observatory. Now this is just the first such observation and of course the first explanation. There of course might be other alternative explanations in the future, but at least for now this makes total sense. It also solves a major mystery of massive black holes and validates an important assumption about black holes and how they're formed in the early universe. Hello wonderful person, this is Anton, and today we're going to be discussing one of the stranger galaxies out there. A type of unusual galaxies that are extremely rare in the universe, and a type of a galaxy that was completely by accident discovered back in 2007 by several amateur astronomers using a citizen science project. But more importantly, or more intriguingly, a type of a galaxy that was also recently discovered by the James Webb in one of the recent observations. Something that you can see right here in this image, specifically in the image on the right, because this galaxy is also extremely redshifted, and so the color here appears red, even though in reality, this galaxy is almost entirely green, like you see on the left. And because of their unusual appearance, in the last decade, a lot of scientists have been referring to these galaxies as green Pea Galaxies, or just green peas for short. And that's because naturally, they seem to be kind of spherical in shape, and they also seem to be extremely green. And it's actually their greenness that presents a bit of a mystery. Mostly because they seem to be one of two possible objects emitting this unusual type of light. And that's because, despite a variety of colors we can find in various galaxies out there, the majority of galaxies will still have relatively similar colors. And a lot of smaller spherical galaxies, similar in shape to the ones that were just discovered called green peas, are very often blue in color because they contain a lot of really powerful stars, creating a lot of energy and also creating a lot of light. Whereas other galaxies might appear a little bit more yellow, especially if they contain a lot of much older stars and do not contain a lot of activity. But generally they'll all contain relatively similar colors, sort of similar to what you see right here. But as you can kind of see, there's really no green here, mostly because there are no green stars. And one of the older videos on the channel that you can find in the description goes a little bit more through the idea of why there are no green stars possible. But there are still green things out there that we have found even in the Milky Way. And they usually look something like this. This is a typical planetary nebula, or essentially a very thick cloud of gas around a central star, usually a white dwarf, with the radiation coming from the central star ionizing the gas and making it shine in various colors. And though these can be a lot of different colors, when this gas is predominantly oxygen, it creates an effect that's often referred to as the doubly ionized oxygen glow, something that always ends up producing exactly the same color. And back when this particular glow was discovered by the early astronomers, specifically in the 19th century, they actually even thought that this was some kind of a new element. They referred to it as nebulium. But today, based on various experiments, we know exactly how all of this works. And so it's really due to the presence of oxygen that this beautiful cat's eye nebula receives its green color. And the same goes for pretty much all of the other objects, although some seem to predominantly contain oxygen, which already creates a bit of a mystery. It means that when this particular star started to lose a lot of its gas, for some reason oxygen was the predominant gas. But that's another mystery to explore in some other video in the future, because today we're focusing on the other source of this green glow. Except for planetary nebula, Turns out that green glow can also come from entire galaxies. And this image from the Hubble Space Telescope sort of shows us 8 of them discovered in the last decade. And this is really intriguing because here, something else is creating this oxygen, and then something else is illuminating it, creating the glow we see from really far away. And some of these galaxies that seem to be located at a very specific distance, equivalent to a redshift of 0.25, seem to possess extremely similar features and all seem to look very similar to one another. For example, they generally have a mass of about 3.2 billion solar masses, that's on average, with a star formation of about 10 solar masses per year. Or to rephrase this, they're about 400 times smaller than the Milky Way galaxy, but seem to produce stars at least 5 times faster. They also do not contain any active nucleus, or basically the black hole in the middle does not seem to be active, yet despite of this, they're relatively easily visible because of their extremely fast star formation and very specific emissions producing that green light. And overall, they seem to represent the least massive yet the most active in terms of star production galaxies in the local universe. Or in other words, compared to all of the other galaxies we've discovered, on average they seem to produce the most stars, despite their relatively small size and despite their relatively small mass. But there are other small galaxies, dwarf galaxies, specifically the galaxies known as BCD or Blue Compact Dwarf, that also have quite a lot of star production, small mass and small size. Here's one. But as you can see, there is no green glow around them. So it's really that presence of oxygen around the galaxy that's then illuminated by all of the new stars that makes these galaxies extremely different and extremely unusual. On top of this, it was discovered that they have a much stronger magnetic field compared to a lot of other galaxies, and for the most part seem to contain a lot of young stars, although some old stars have been found in them as well. They also generally seem to be completely by themselves. No partners, and also located in a relatively low intensity environment where there's just not enough material. But one of the main reasons it took so long to discover these galaxies is also because they are relatively rare. At the moment, only approximately 40,000 have been discovered out of obviously billions or actually even trillions of galaxies out there, which means that, at least in the local universe, these galaxies do not seem to be very frequent and represent something that might have existed a long time ago, but does not exist much anymore. And this is a really important part. The properties observed from these galaxies actually suggest that these types of galaxies must have been super frequent a long time ago, and because of their extremely high energy and a lot of ionization power, which by the way causes this green glow around them, their discovery excited the scientists for one main reason. They might finally explain how the universe became reionized, how the universe went from being relatively opaque and somewhat difficult to see through, to essentially transparent like it is today. This period is known as the reionization period, and even today it's not entirely clear what exactly was responsible for making it happen. It could have been really powerful stars, or exceptionally bright and extremely powerful black holes, but with the discovery of green peas, they sort of became the new explanation. It possibly was a very specific type of galaxies that existed a long time ago, and has since become extremely rare. And so if the reionization period was mostly caused by these unusual galaxies, it means that we should be seeing more and more of them as we look deeper and deeper in time. And obviously, to reionize the entire universe, you would require a lot of energy and a lot of these smaller galaxies. Which is exactly why the scientists were so excited to discover 3 of these green pea galaxies with extremely similar properties and features to what we actually observe much closer to us. As a matter of fact, the spectroscopy analysis revealed that they were practically the same, containing very few heavy elements, a lot of oxygen, with the oxygen then ionized at a temperature of about 50,000 Kelvin, suggesting that these are very powerful objects. Most of this reionization is probably caused by very massive, very hot stars, responsible for all of the star production in the galaxy as well. And because these objects are visible in a universe that was only 700 million years old, compared to the previous object that was discovered when the universe was already 10 billion years old, and because 3 were discovered in a relatively small volume of space, it does indeed imply that these galaxies were extremely common during the reionization period, possibly suggesting that, at least to some extent, they were responsible for making the universe transparent once again. And although obviously it could have also been different types of unusual stars, and of course black holes, the discovery of these very powerful galaxies is definitely one of the more exciting discoveries coming from the James Webb in the last few months. But despite all of this, we still barely know anything about them. Nobody knows how exactly these galaxies evolve or how they form. what relationship they have with other galaxies, or even what happens to them at the end. Do they become something else? Do they eventually sort of disappear, becoming invisible? And more importantly, why is it that we don't see anything in between those two ages? Why is it that no such galaxy was discovered in a period between about 1 billion and about 9 billion years throughout existence of the universe? Is it that they suddenly disappeared and reappeared again? Or is there something else going on here that we just don't understand? Which of course means that it's still an extremely mysterious type of a galaxy. Probably one of the most mysterious discovered in the last decade. So looks like James Webb Space Telescope finally achieved it. We finally have images from all 4 giant planets in the solar system, with all of the data now collected and ready to be analyzed. Hello wonderful person, this is Anton, and so today let's start with what was just released by the team processing all of the data from the James Webb. Well, it actually started with this, an intriguing picture of Saturn, but in this case, an image that was still not processed, an image that is still kind of difficult to understand. This is essentially the raw data that you can technically even download yourself, because all of this is publicly available. But it didn't take very long before the first images that were processed started to appear as well. With this one I think being the best so far. And this is Saturn, visible in the infrared frequencies, with other images focusing on other details, revealing more things that were invisible previously. Which of course means that we now have all 4 planets imaged in the infrared and investigated by the James Webb. It took just over a year to get all of this, but it's probably going to take a few months before all of the studies that were focusing on all of this data are going to start coming out with all of the new findings from all of this huge amounts of data. And so at least for now, we get these beautiful images showing us these 4 planets like we've never seen them before. Intriguingly though, as you can see, Saturn, Neptune and Uranus seem to contain easily visible rings. Jupiter though does not. And that's because the rings here are a little bit more difficult to see, predominantly because they're made out of slightly different material. Although if you want to learn more about this, and you want to learn more about Jupiter, Neptune and Uranus, and all of the discoveries made so far, check out all of the previous videos in the description below. Nevertheless, from all of these 4 images, we definitely get to see these planets in a way we've never seen them before. For example, for Jupiter, we seem to observe these permanent aurora that are generally invisible in optical wavelengths, but are definitely visible in higher frequencies or in the infrared, with the rings also generally invisible in the optical light, but once again visible with infrared frequencies. When it comes to Neptune, which is the farthest of these planets, this is probably the most detailed image we have ever since the Voyager 2 flyby in 1989. And here I think it's the rings that are probably the most exciting, as well as tiny moons visible inside the rings as well. Here's the annotated version of this, and as you can see, one of the brightest objects is the large moon Triton, the moon that's potentially extremely similar to objects like Pluto. But we also get to see other 6 moons, with 7 other moons invisible in these images. But the other intriguing part is of course these unusual bright spots in the atmosphere. These are very likely active storms, and seems to suggest an active global atmospheric circulation present on this planet. This can be barely seen with optical light or with telescopes like Hubble, and some of the previous discoveries from Hubble have actually created more mysteries than answers. Here though, we might be able to get some closure once the scientists figure out how this atmosphere works. And then of course we got these strange images from Uranus. The planet is, as you can see, completely on its side. But once again here, it's the rings that seem to take precedence. They seem to be very well ordered and create these very beautiful, unusual patterns. And as we've recently learned from studies on Saturn, rings in general can be used to study the atmosphere of the planet and to even discover unusual anomalies inside the atmosphere by looking at various variations and patterns formed inside the rings. I'm sure the studies about this are going to come out, possibly in the near future. And so this beautiful image reveals 11 out of 13 different structures present inside this beautiful ring system. But once again, an unusual brightening that seems to be very close to the polar cap. And though it's kind of similar to what we saw on Neptune, here it's much bigger, and its origins are currently unknown. But the most intriguing thing about both Uranus and Neptune is that despite similarities, in infrared light they do seem to have very different colors. Here's by the way the zoomed out version showing us some of the moons as well. And so it's the coloration here that seems to be a bit of a mystery. Generally the scientists believe they do contain similar materials, but the properties in their atmospheres seem to be different enough to produce different visual effects. What's exactly happening here is, of course, not something anyone can answer right now. And now we have our fourth addition, Saturn. And this one I think is probably the most unusual and the most unexpected. Here's of course what Saturn looked like before, with images taken by the Hubble telescope in optical light. And one prominent feature that's definitely visible in the optical light are these unusual stripes visible on the surface. But these features disappear in the infrared light. And because infrared temperatures generally show us heat or thermal properties, it sort of suggests that the temperature here is more or less the same, with what seems to be polar regions that are once again slightly different in color. I actually thought that this image from practically 20 years ago presents us with a very interesting contrast. Here you can see the visible light, the ultraviolet observations, but also some of the first observations in the infrared. This was by the Hubble telescope as well. And here, the stripes were still kind of visible, but this was in different frequencies. Because James Webb is able to see much deeper in the infrared light, and because it's not showing us any optical observations, all of these unusual stripes completely disappear because of methane-rich upper atmosphere that pretty much blocks all of the clouds underneath, and thus obviously blocks the heat as well. But we do see some kind of an unusual dark shape visible in the northern hemisphere that's possibly created by some kind of aerosols present way above methane clouds. But it's still kind of surprising how different it looks from Jupiter. First of all, no aurora visible whatsoever, and second of all, no unusual storm-like features, or really any features, that we do see in optical light, but that are pretty much absent here. But unlike the atmosphere, the rings are definitely very easily visible, along with several moons. And it's really intriguing how it's the rings that seem to be the brightest objects in this entire image, much brighter than the planet itself. And so in this annotated image, you can definitely tell apart the dark C ring, the very bright B ring, the Cassini division, the somewhat bright A ring, and the unusual Anki gap that ends with the F ring at the end. But because this is just the first image, we still don't get to see the other rings that should be visible on the outskirts as well. As a matter of fact, the G ring that should be visible seems to be absent, as well as the large diffuse E ring that is believed to be produced entirely by the moon Enceladus that you see right there. And that's of course the other major discovery coming from the system in the last few months. A major discovery coming from Enceladus itself. The strange, mysterious, and very exciting moon that you see right there. Once again, the center of the E ring. This by itself is clear evidence that it's creating the entire structure. And so as we've known for many years now, Enceladus has these very large emissions that, as we've recently discussed, don't seem to be geysers or even volcanoes, but instead seem to be a result of very violent sudden evaporation as the liquid water from within is exposed to outer space. And this of course ends up extracting a lot of materials from within the internal ocean and releases it into the rest of the Saturn system. And intriguingly, unlike other objects in the solar system that have a lot of water and extremely large oceans within them, Enceladus doesn't actually have that much, at least by mass, but it seems to be approximately 14% liquid water, making this one of the most water-enriched moons, or really any objects, in the entire solar system. But it still very likely contains a really large rocky body inside of it, which is probably made out of some kind of a carbonaceous chondritic rock, potentially similar to various asteroids that orbit everywhere in the solar system. And because of the tidal interactions with Saturn and with the other moons, there's basically a lot of mixing and a lot of sloshing of this relatively small ocean with lots of different organic molecules present inside this unusual core, with many of these molecules then making it to the surface and eventually being expelled through these unusual jets produced by the moon. And extremely recently, the scientists identified something nobody expected: phosphates. The same stuff that our DNA and RNA are made from, and also the same stuff that our whole body uses for energy. And of all possible molecular discoveries, so far this is actually one of the most exciting ones. Mostly because finding phosphates in an ocean on an alien world dramatically increases the chance that we might discover some kind of a strange, unusual life. But more importantly, organic life. Life similar to planet Earth. And more importantly, the chance of this happening on Enceladus has now increased dramatically because all 6 important elements of life, carbon, hydrogen, nitrogen, oxygen, and sulfur, have also been discovered here as well. This moon seems to contain everything you would need to create primitive life. And with the discovery of sodium phosphates, it's basically now all about just going there and trying to see if there's anything present in those oceans underneath the ice caps. Although the only way we could probably ever come here is by using some kind of an advanced rover that can dig through all of this ice and then explore the ocean. Intriguingly, NASA and JPL is currently testing such rover right here in California mountains. And this is really cool because it's basically some kind of a snake-like object that's able to move on the surface but also able to dig deep into the ground. You can learn a little bit more about this in one of the videos in the description, but in essence this is maybe the future of Enceladus mission. A somewhat strange, unusual, but somewhat effective snake-like object that's able to explore the oceans underneath. And because it's already been tested successfully here on Earth, it's now just a matter of time before all of this can be planned officially and launched sometime in the future in order to explore this unusual moon. I think this image right here represents this really well. If successful, this would be the most exciting mission ever and potentially make incredible discoveries underneath. But all of this was really made because of these observations inside the E-ring made with the James Webb Space Telescope. And so now we have really good reasons to try to go there and to potentially finally have an answer for, is there life out there outside of planet Earth? Because at the moment, Enceladus is definitely that one location that seems to show the most signs. But if the life here doesn't exist, and also if the other exciting moon, Titan, reveals no signs of life either, well, that's when we have to start asking bigger question. Is life just very unique and extremely rare? But these are of course just first observations of this beautiful system and the first images coming out of James Webb. Here, the northern hemisphere is actually currently reaching the end of its 7-year-long summer, and so the images will probably change in color and look very different in the next few years. Which by the way might help us answer what's actually happening right here in the northern region. Okay, looks like we have another intriguing discovery coming from the James Webb Space Telescope. And this one once again in regards to galactic evolution. But this time even more surprising than before. Most likely confirming that the current understanding for how galaxies evolve is probably wrong. But not because the Big Bang did not happen or because the universe is much older than we originally thought. Actually quite the opposite. The Big Bang and the overall age of the universe was confirmed in a separate study around the same time. Instead, what these new discoveries present is a completely different stories for how various galactic shapes seem to evolve over time. Ironically, something very similar was discussed in a separate paper and in a separate video from just a few weeks ago, where we actually discuss how the current model for galactic evolution is most likely wrong. It needs to be rewritten. And these James Webb Space Telescope observations physically confirm that this is definitely true. And so, hello wonderful person, this is Anton. Let's discuss these two new papers, what exactly they discover and what it means, and also talk about a few things that we still cannot explain. And I guess let's start with the obvious. So approximately 100 years ago, the famous Edwin Hubble officially discovered the universe. He basically found evidence that various unusual spiral nebula were actually individual galaxies really far away. Up until that point, it was actually believed that the universe was just the size of one galaxy and was our galaxy, the Milky Way. Everything else was inside of it, with different objects around us just being different nebula. But pretty quickly the scientists realized that that's not the case, and we do have so many different galaxies out there. And within just a few years, Hubble was able to work out how various galaxies seem to connect to one another. He proposed what's known as the Hubble classification scheme or the Hubble tuning fork. The idea that different types of galaxies evolve into one another based on the interaction nearby and of course based on their age. Everything starts with the elliptical galaxy that turns into a lenticular galaxy, which then becomes some kind of a spiral. But as we discussed in that previous video in the description, that might not be the case. And so over the years the scientists realized that this particular picture doesn't really make sense. Because here the idea was that we should actually be seeing a lot of elliptical galaxies in the ancient universe, quite a few lenticular galaxies somewhere in the middle, and quite a lot of spiral galaxies in the modern universe near us. Now we do see quite a lot of spiral galaxies close to us, but when it comes to looking back in time, things get pretty complicated pretty quick. And though the galactic evolution itself is still not super clear, what's clear is that this seems to be wrong. But let me actually give you some visual evidence from the Hubble Space Telescope in order to see why this was believed to be true for many years. And in just a minute or so, we'll also take a look at the data from the James Webb Space Telescope. So over a decade ago, Hubble was able to collect huge amounts of data. And it was also able to see quite a lot of distant galaxies. Quite a lot of them resembled something like this. They were basically all somewhat spherical and all resembled something that seems to be elliptical in shape. And all of these galaxies were billions of light years away from us. Here's one of the closer examples from the Hubble, NGC 2865. And so many galaxies that it was seeing far away were basically kind of like this. And in terms of evidence and mathematics and logic and previous predictions, all of this kind of made sense. But by looking even farther back in time, we should be detecting more irregular galaxies or galaxies with very peculiar shapes. So basically shapes that are not entirely defined. And that's because in this case, the galaxies are still colliding, still forming, and are still somewhat unstable. To some extent, some of these galaxies were actually seen by the Hubble as well. But Hubble was mostly good at seeing optical light. It was not a telescope for seeing infrared or for looking even farther back in time. So it had its limits. And it was of course able to confirm that in the nearby universe, spiral galaxies were extremely common. Basically, this is the most common type of a galaxy nearby. And of course, based on the planet Earth, it was also assumed to be the type of a galaxy most likely to have Sun-like stars, Earth-like planets, and potentially life. But based on these observations, the other assumption that was made previously suggested that in terms of spiral galaxies and in terms of their formation, they actually should be a more novel development. As in prior to a certain period, they actually should not exist at all. Some of the previous studies suggested that up until the universe became 6 billion years old, it was most likely impossible to have these galaxies around, basically suggesting that it probably took at least 7 billion years for many of these galaxies to finally stabilize their shapes. That of course includes the Milky Way. And once again, based on that Hubble data, there was very little reason to doubt any of this. Many of these galaxies were elliptical or irregular, and none of them seemed to be spiral. And then James Webb goes, hold my beer. I mean, really hold it, because I have no hands. And basically goes and looks at the same galaxies one more time, discovering things that were previously completely invisible, and in essence uncovering that pretty much most of those galaxies that were previously believed to be elliptical were actually just the visible cores of much larger galaxies that were spiral, or at least disc-like in shape, possessing that perfect disk structure, with many of these galaxies observed as far back as 10 billion years ago, and also representing the most common type of a galaxy back then as well. And though these galaxies were always believed to be somewhat fragile to exist so early on, the evidence is pretty clear. They definitely existed, and there were quite a lot of them as well. As a matter of fact, the evidence suggests that there were at least 10 times more of them than ever predicted. With this observation potentially presenting new problems, but also new exciting opportunities. Although first of all, let's actually get the obvious out of the way. No, it doesn't mean that the Big Bang didn't happen, and it does not mean that the universe is much older than we originally believed. I'll explain to you why in a minute or so. But it does mean that the theories of galactic evolution, the ones that we have right now, are just extremely primitive and do not explain everything in the way that they should. So for example, on the one hand, it seems to suggest that the entire structure in the universe very likely formed much quicker, implying that there is definitely something guiding everything and that something prefers these disk shapes as that preferred final result. Right now, the best explanation for that something is the mysterious cosmic web, something we've discussed many times before and something we have a lot of evidence for, basically this unusual formation across the universe that seems to direct and guide everything. All of the matter, all of the galaxies, everything in those galaxies. And so for some reason, it seems to like forming disk shapes. Not necessarily spiral disks, sometimes just flat disks that we usually refer to as lenticular galaxies, which are also very common in the universe as well. Here's one of the most famous ones, NGC 2787. But either way, they seem to be the most common and, to some extent, the most likely to form during most periods in the entire universe. And so even though previous observations by the Hubble predicted most galaxies to be irregular or peculiar, at least at the redshift of 1.5 to approximately 6.5, and that's over 6 billion years in the past, the James Webb observations, with approximately 4,000 different galaxies observed and analyzed very thoroughly, revealed a lot of hidden structures. Some of them could be lenticular, and some of them could be spiral. And most importantly, this included very massive galaxies with masses similar to the Milky Way. So basically relatively old galaxies that started developing a long time ago and evolved over billions of years. Intriguingly, this also implies that the majority of stars in the entire universe very likely evolved inside some kind of a disk galaxy. Not a regular galaxy, not elliptical, most likely a disk-like galaxy similar to the Milky Way. That by itself is already a pretty big discovery, especially when it comes to the idea of extraterrestrial intelligence somewhere out there. It sort of dramatically boosts the chance for the existence of some kind of alien life out there, quite dramatically. To some extent, this also confirms the previous observation and the previous scenario I've discussed in that video in the description, confirming that galaxies do evolve very differently from how we originally thought, but more importantly, once again suggesting that we just don't get what is actually guiding the galactic evolution across the entire universe. Now, it's assumed to be some kind of an invisible force, like maybe dark matter, but at the moment, it's unknown. Hopefully James Webb will be able to answer this really soon. But what about that idea that maybe Big Bang never happened, or that maybe the universe is much older? Well, this is where this other study comes in, pretty much using a very similar dataset or very similar galaxies. Dilution of chemical enrichment in galaxies 600 million years after the Big Bang. And here, by looking at even older galaxies, scientists wanted to confirm or possibly disprove the relationship between galactic mass and the amount of heavy elements in each of the galaxies. The idea here is really simple. If a galaxy is really old, it should be pretty massive. If a galaxy is really old, it should also have a lot of heavy elements that are not just hydrogen and helium, naturally the result of various supernova and the evolution of elements. More massive galaxies should have more heavy elements. But here the scientists once again discovered something maybe a little bit different. Still easily explainable, but just not what they expected. Even though the relationship today sort of looks like this is heavy elements versus galactic mass, those early galaxies had it more extreme. Less massive galaxies had significantly less heavy elements compared to what was originally predicted, which in essence implied that they were extremely underdeveloped and there's no way that they're older than just a few million years. In this case, this was approximately 4 times less amount than predicted. And though this might seem like another problem, this is actually not a problem at all, because here we're looking at early universe, where we're basically witnessing galactic formation in the process. Huge amounts of hydrogen and helium moving into various galaxies really fast, and helping them grow really massive really quick. Because according to this explanation, if the actual observation was very similar to how it is today, or basically if this relationship was similar to this, you would assume that this galactic equilibrium was reached much earlier and the universe could have been much older. But because we actually seen this, it presents us with the image of very light gas, hydrogen and helium, mixing into smaller galaxies, helping them grow and develop really fast. Much faster than in modern universe. And so basically, this is a confirmation of the Big Bang theory and the dramatic evolution of the universe in the first billion years. And so in this case, the observations from the James Webb both present us with a new mystery and a very specific explanation for why the Big Bang is most likely the best explanation we have. In just over a year, the James Webb Space Telescope made some of the most incredible discoveries from pretty much every point in the universe, many of which we've discussed previously on the channel, and many of which have been pretty groundbreaking or quite mind-blowing. But when it comes to trying to understand the universe, trying to figure out its secrets, quite often one of the best ways of doing this is by looking at various anomalies and trying to explain them in some way. And though obviously it's not always possible right away, it usually does lead to some incredible discoveries. And so, hello wonderful person, this is Anton. In this video we're actually going to take a look at some of the more recent and some of the most incredible discoveries from the James Webb, some of which are still kind of difficult to explain, and some, even though we understand pretty well, just uncovered even more mysteries. And specifically we're actually going to talk about some very unusual and somewhat accidental or lucky discoveries of different types of images that were never meant to be taken and just happened to be in a picture somewhere. With this one of course going viral just a few weeks ago. The very unusual formation forming a question mark. It's actually part of this image we discussed very recently that shows us a baby star, sometimes referred to as the Herbig-Haro object. And so this unusual question mark is hiding right here. You can actually learn about this in one of the videos in the description. But even now it's unclear exactly what this is. Based on the redness, it seems to be some kind of a very distant galaxy. And if it is a galaxy, there are two possible explanations. Either an extreme warp from a galactic collision with somewhat similar images seen previously, or this could be some kind of a gravitational lensing effect that has been seen many times before. And so honestly, at the moment, it's not really clear. Although I'm sure in the next few months, someone might figure it out. But while doing research about this image and basically discovering nothing, I came upon several really exciting papers that actually also accidentally discovered something that we do understand pretty well, but something that's exceptionally rare. So yeah, once again, it's this. But not just gravitational lensing effects, we're talking about the ones forming a perfect shape, the Einstein ring. And it's the ring that you see right here. Now this is actually exciting for several reasons. First of all, this is a new record holder, the farthest Einstein ring ever seen. The galaxy that's being warped is approximately 21 billion light-years away from us, with the lens itself being about 17 billion light-years away from us, with the light here taking approximately 10 billion years to reach us. And just like every other ring, it's of course formed in the same way. There's a very massive galaxy in front, and right behind it, somewhere far away, there is some kind of a somewhat bright galaxy. Although interestingly in this case, this particular galaxy does not seem to be too active, or actually even that bright. The scientists refer to it as a quiescent galaxy, suggesting that it's barely producing any stars. But since most gravitational lens objects normally form an incomplete arc, finding such a perfect circle is really extreme. This is actually the only one so far out of 500,000 galaxies captured by this particular survey. It's known as Cosmos Webb, and it essentially covers the area that you see right here. And so in that area, size of the moon, this was the only such object. They are super rare. As a matter of fact, this is only the second such ring discovered by the James Webb after just over 1 year. This was the first one that was seen a few months prior by a different survey. And this particular discovery revealed a galaxy extremely rich in various organic molecules, which back then was a pretty exciting discovery. Definitely not something anyone expected. It's not clear yet what we're going to discover here, but some of the preliminary observations are already kind of extreme. First of all, the calculations for the nearest galaxy, the one that's lensing everything, suggest that it has a mass of about 650 billion suns. And because it's able to produce such a perfect circle, the only explanation we have right now is that it seems to be incredibly dense and contains a lot of mass in a very small size. And though naturally this could be explained with dark matter, according to the scientists behind this paper, even this is probably not enough as an explanation. Normally we expect about 85 to maybe 90% of the galaxy to contain the invisible dark matter. But whatever is happening here is way more extreme. With the main conclusion in the paper essentially stating that we actually need some kind of additional mass to explain exactly what's happening here. So this lensing galaxy is already creating a bit of a mystery. It's not clear what this extra mass is. Although one suggestion was that maybe it just has a huge amount of very small, barely visible stars, making this a somewhat compact, barely visible galaxy. In some sense, somewhat similar compact, dense objects have already been discovered by other surveys using James Webb. And so whatever the answer is, dark matter, extra stars, or something else, we'll probably discover in the future. But intriguingly, the explanation for a lot of these rings discovered previously, including by the Hubble telescope, essentially involves the existence of these somewhat compact, somewhat small galaxies that might have existed a long time ago, but potentially turned into something else over time. Because honestly, in order to produce such a perfectly circular ring, you do need to have a very small, very compact, and pretty much equally distributed object that seems to contain a huge amount of mass, billions and billions solar masses. And so even though such galaxies could be very rare today, it does look like, based on observations of these rings, that many such galaxies were quite common 10 to maybe 12 billion years ago, when the universe was still developing, especially during the period sometimes referred to as the cosmic noon. The period when the galaxies were super active, when there were a lot of different quasars, and the star formation was at its maximum. So it looks like back then the galaxies were just maybe a little bit different. At least that's the main explanation we have right now for why pretty much all of these rings seem to be only visible in a relatively ancient universe. But when it comes to ultra-rare objects, it doesn't get more rare than this. A double Einstein ring. A ring inside the ring, basically involving 3 different objects, all in the same line of view from planet Earth. As far as I know, this is the only such object we've ever discovered. And though the new discovery is just a regular ring, it still beats the record for the distance. And because this is a ring taken by the James Webb, we're probably going to be discovering a lot of different details about the composition of these galaxies in the next few months. Although once again, I guess the biggest question here is really, what are these galaxies in the middle? What is forming these massive rings? It has to be a really massive galaxy, and it has to be really compact, potentially just a few thousand light years across. And if these galaxies did exist back in the days, there's really no explanation to how they formed. Okay, maybe actually one explanation. Some scientists believe that maybe these galaxies formed inside out. They started with a huge core in the middle and then somehow accumulated extra mass around them. Which, if confirmed, would be a pretty interesting way to form a galaxy. So even by themselves, these galaxies already form an exciting mystery. But when it comes to strange gravitational lensing effects, there have been definitely quite a lot in just the last few months. Here's one of the more interesting ones, detected in the vicinity of the cluster known as Earendel. We'll discuss this cluster in a separate video because there have been some exciting discoveries here in regards to the mysterious dark matter and the potential violation of certain laws. So subscribe if you don't want to miss that video. But anyway, so approximately 60 galaxies were discovered lensed by this cluster, with most of them previously unknown to us because the Hubble telescope was just unable to see them. Here's actually one of the exciting images comparing previous images from Spitzer to the recent images by the James Webb. And so quite a few unusual distortions have been discovered inside here as well. For example, this fish hook, as it's now referred to, appears to be wrapped in a very strange way around the cluster. It's kind of unclear why it's formed this way. And here, based on the red coloration, we can only assume that this is a very dust-rich galaxy, and it's also redshifted, suggesting that it's far away. But obviously, why it's warped this way is currently unknown to us. Likewise, another unusual warping is what the scientists refer to as the thin one, literally because it's so thin. Once again, uncertain why this forms such an unusual line, but it essentially seems to be a galaxy edge-on and potentially stretched on top of this. Here, one of the reasons this galaxy looks so strange is actually because it's really far away. The light here took approximately 11 billion years to reach us. So this is a really powerful magnification effect. But just like with this discovery, at the moment these are just visual confirmations, and we don't really know exactly what's happening in those galaxies, or why these lenses are formed in such an unusual way. It definitely tells us a little bit more about the distribution of mass inside this Elusive cluster, but the actual details are not there yet. But there are 4 different scientific papers in the description that in essence analyze this in more detail, sort of cataloging all of these structures and all of these formations for a lot of future studies. As you can imagine, and as you can see from this image, a lot of stuff has been discovered here, and most of it is still unknown. But like I mentioned in the beginning, it's really from these anomalies and from these unusual observations of strange phenomena that at first don't make sense that we're actually going to learn more about the universe and potentially figure out what exactly is going on, and of course, what's driving the entire universe. So this picture you see behind me, this is a result of approximately 250 hours of direct observations by the James Webb Space Telescope, part of a large survey by the James Webb that's actually meant as a kind of a general observer program. It doesn't have a specific purpose, but it's very similar to what Hubble did a few decades ago. Similar to the iconic ultra-deep field, but here we only see approximately 10,000 galaxies. The image by the James Webb shows us at least 3 times as many. And this is just the first such image. It took less time to produce, and it shows us so much more. And we now even have this very beautiful animation created by NASA that shows us a simulated flight to a now famous Macy's galaxy, one of the most distant objects out there, named after the discoverer's daughter, Macy. This is at a distance of billions and billions of light years away from us, when the universe was only a few 100 million years old, with that really dim dot that you see essentially being that unusual galaxy. And so, yeah, hello wonderful person, this is Anton, Today we're going to be discussing some of the recent updates from the James Webb Space Telescope, mostly focusing on more unusual unexpected discoveries from the super distant universe, some discoveries that still make no sense, but also some discoveries that sort of reveal things we kind of expected. And here's one such image, something that we knew we were going to find at some point. The image of earliest galactic collision ever found. This happened when the universe was about 500 million years old, intriguingly showing us two somewhat different galaxies. One is much bluer and contains a lot of young baby stars and a lot of star formation, whereas the other one seems to be red, contains a lot of dust and not a lot of new stars, with one of the galaxies at least 10 million years younger than the other. And this discovery beats the previous record of galactic collision by at least 300 million years. But discovering galactic collisions so early on, and possibly finding a lot of them, was of course always expected. In some sense confirming a lot of cosmological theories when it comes to galactic evolution. But a much more exciting discovery of something that was expected but was still surprising is right here, with each circle representing one of 10 galaxies existing when the universe was about 830 million years old. Now why is this exciting? What are we possibly looking for? Well, based on the current analysis, the conclusion here is that we're looking at one of the threads of the mysterious cosmic web. Specifically a thread that's about 3 million light years in length and that seems to be connected to an ancient quasar, a galaxy with a very active supermassive black hole on the inside. Now, the cosmic web by itself is a major prediction of a lot of modern theories, but it's not until the last few years that we actually started finding physical evidence for it in a lot of different images. There's at least one video in the description that explains some of this evidence in more detail. But in this case, what it seems to show us is a filament that might eventually evolve into a massive galactic cluster, with galaxies currently approaching one another along the filament itself, possibly serving as a formation theory for various massive galactic clusters, such as the famous Coma cluster. And so in this case, this is basically one of the earliest filamentary structures that seems to be directly associated with the ancient cosmic web. And it seems to be really thin and very long, as I mentioned, 3 million light years in length. So definitely a somewhat unusual discovery, even though technically, theoretically it was predicted a long time ago. But in the last few months, some of the most exciting discoveries were really in regards to black holes. Pretty much every single week, dozens and dozens of new black holes have been revealed by new observations, with scientists now suggesting that we've discovered at least 10 times as many black holes as everyone expected compared to what we used to have a few years ago. Although in this case we're only talking about really massive black holes, central black holes in various galaxies. So obviously black holes like this one that would form a quasar, or any other black hole that's usually referred to as an active galactic nucleus, AGN. And so why exactly there seems to be 10 times as many as everyone expected, that's the mystery for now. I think this study right here sort of summarizes everything in a lot of detail. But here are just some of these new images showing us each of these black holes at a relatively far away distance. They basically look like extremely bright infrared blobs, but specifically blobs that seem to be different from the surrounding galaxy. And so the further analysis using spectroscopy can easily reveal if the brightness here comes from the black hole or from various stars in the galaxy. And so it looks like a lot of this superheated gas in many galaxies does come from these very powerful black holes. And intriguingly, many different discoveries in the last few months involved a lot of record holders as well. The biggest story though is probably this, Sears 1019, an extremely distant early galaxy that contains a relatively massive black hole in the center. Here the universe was only about 570 million years old. And strangely enough, this galaxy appears as these 3 bright clumps, implying that it's still assembling itself and does not have a disk or any structure. It's also very likely forming stars really quickly, with the black hole growing fast as well at the same time. The total mass of the black hole is approximately 9 million solar masses, twice as massive as the one in the center of our own galaxy. And the reason this black hole is visible to us is probably because of some kind of a galactic collision that happened here relatively recently. And so strangely enough, the calculations here suggest that this black hole is growing at the fastest possible speed. It cannot possibly grow any faster, at least theoretically based on what we know about black holes, which is of course why it's also so bright and so easily visible. But in terms of mass, it's not particularly massive when it comes to large black holes. Approximately 2 years ago, even before the James Webb, there was a discovery of a black hole that's about 1.6 billion solar masses, hundreds of times more massive than this one, when the universe was just 670 million years old. Now that discovery is still difficult to explain. It actually sort of violates what's known as the Eddington limit, suggesting that we just don't understand exactly how massive black holes form. A lot of these ideas are still based on somewhat outdated principles, and we even have some of the new discoveries that you can learn more about in the description that actually explain how certain massive black holes can form extremely quickly without breaking any rules. And so the discovery of these unusual black holes, though unusual, definitely does not break anything major. But intriguingly, even just a few weeks ago, there was a potential discovery of a massive black hole even farther away, redshift of about 12. With all this hinting on the fact that some of the observations imply that our theories definitely need to be changed just a little bit. Not only do these black holes seem to grow to large sizes really quickly, there seem to be at least 10 times more of them discovered by the James Webb. And the most recent discovery was from the paper that you see right here, in regards to an extremely bright X-ray object known as UHZ-1. Here the redshift is approximately 10, so it's slightly closer to us, but it seems to represent some kind of a very unusual black hole because it seems to lack certain signatures we expect from an active galactic nucleus. And one property that makes this black hole somewhat unusual is actually the fact that we don't see much. A lot of things seem to be hidden, which actually implies that there is quite a lot of dust present here that seems to hide a lot of the emissions. And the main conclusion in this paper is actually the fact that this might help us answer how these black holes become so massive. This idea is usually referred to as the seeding model, and these seeds can actually be anything. It could be really massive stars, early stars such as population 3 stars, possibly thousands of solar masses in mass, or they could also be chunks of dark matter. But in this case, this particular galaxy has a really high chance of potentially answering many of these questions, with many of these other black holes providing more evidence and more explanations for what exactly allowed them to become so big so quick. But we'll talk more about this once there are actually some answers. But then we have this other unusual mystery that really no one expected, coming from a barely visible galaxy at a redshift of 7. And here it was a discovery of carbon, specifically carbon-based molecules or carbon-rich dust grains. Okay, cool. Why does carbon matter though? Well, it's not why it matters, it's I guess when it matters. Some of these complex organic molecules technically should not exist yet. For example, in our own galaxy, the most common discovery of carbon molecules in most star-forming regions involve what's known as PAH, polycyclic aromatic hydrocarbons. Something we usually find in the middle of various molecular clouds, something that we also associate with formation of planets and stars, and of course potentially complex life. It's usually found in various birthplaces for many different planets and stars, and it seems to be responsible for the evolution of various galaxies. Ironically, in astronomy, it's also a bit of an issue. It absorbs a lot of wavelengths, and so it actually makes things a little bit difficult to observe if, for example, you're trying to look through the whole galaxy with a lot of these carbon molecules absorbing a lot of light. And so what's the big deal of discovering this with the James Webb? Well, the thing is, these complex organic molecules, these cyclical molecules, are not thought to have existed within the first billion years of the existence of the universe. We definitely had carbon, we just didn't have complex organic molecules yet. Modern chemistry predicts that it would take at least several 100 million years to potentially form even the simpler molecules. And so discovering polycyclic carbons in very early universe is definitely a bit mysterious. Naturally, this is where a lot of naysayers are going to start saying, maybe this means that the universe is actually much older, or the Big Bang never happened, and so on and so forth. But that's not the explanation that we currently have for this. As a matter of fact, the current explanation is way more intriguing, and it relies on a minute detail and extremely accurate measurements of certain frequencies. So basically here, it really depends on how this was found. And so in previous research, by looking at galaxies much closer to us, up to a redshift of about 3, a lot of spectroscopic observations often observed similar molecules at a frequency of approximately 217.5 nanometers. So basically, if you see an absorption at this frequency, it's probably coming from various polycyclic aromatic hydrocarbons. But the observations from this particular galaxy were peaking at a wavelength of 226.3 nanometers, suggesting that this was maybe carbon-based, but not exactly what we expect it to be. Or that it was some kind of a carbon dust that used to exist here that didn't form the same complex molecules just yet. Essentially, early universe cosmic dust. Dust that could be easily produced by many different early stars, going supernova and forming early carbon that then mixed with oxygen and other elements to start forming extremely early organic compounds. And at the moment this is the most likely explanation, which also implies that the early universe had extremely different chemistry compared to anything we have today. It also implies that the planetary formation and star formation was probably somewhat different. We don't really know how different, just different. Although this particular wavelength could also be produced by something more simple, maybe various graphite formations created by complex carbon without any organic molecules. So basically here we're looking at some kind of a super early complex carbon dust. Either way though, super exciting and something we're going to be discussing more once there is maybe some conclusion, some explanation, or additional observations from future studies. And then there was this, an actual physical observation of a collision of two neutron stars resulting in a powerful kilonova. Now by itself this is not the first time we've seen neutron star collision, but it's the first time it was seen by the James Webb, detected through a very powerful gamma ray burst that was seen in March of 2023. And the main discovery here was the detection of various very heavy elements, specifically 15 metals heavier than lead, whose existence before was a bit mysterious, but has now been attributed to a neutron star collision. For example, heavy elements like tellurium and various types of lanthanides. This was about 8.3 million light-years away from planet Earth, but strangely enough, approximately 130,000 light-years away from the nearest galaxy. So technically, this could have come from somewhere entirely different. Unfortunately, during this time, the gravitational detector LIGO was not operational, so we don't really have more details. But nevertheless, the discovery by itself is already pretty impressive. Especially because this is not even the first kilonova or supernova seen by the James Webb completely by accident. Here's another one that happened in 2022, and this one was surprisingly a result of a gravitational lens and located billions and billions of light years away. So I'm sure we'll be seeing more of these in the next few months. There were quite a lot of unusual and somewhat unexpected discoveries coming from the James Webb Space Telescope in the last few months, with the strangest one being the discovery of several galaxies really far away from us, many beating previous records by a huge margin and essentially representing the farthest galaxies ever found. Although that part by itself was not unexpected. As a matter of fact, the James Webb was specifically designed to find these galaxies. What wasn't expected, and what was really unusual, is the discovery of relatively massive and relatively well-developed galaxies at these very similar locations. For example, the currently farthest galaxy confirmed right now by the James Webb is at the redshift of 13.2. The galaxy that you see right here, and the galaxy that's about 13.6 billion years old, or approximately 33.5 billion light-years away from us. And if you're wondering why these numbers don't match, check out one of the videos in the description that explains how the redshift works, and how, because of the universe expansion, things are a little bit farther away. Anyway, so this galaxy is the new record holder, and once again is maybe a little bit too developed compared to what the scientists predicted. By the way, there's another study that I'm going to be discussing really soon that even proposes that maybe this is not a galaxy but something a little bit more exotic. I don't want to spoil it just yet, but subscribe if you'd like to find out more. That video coming out really soon. And so because of all of these galaxies, it created a bit of a problem because there was no good explanation. As a matter of fact, it created a kind of a tension when it comes to modern theories and even the theory of the Big Bang, or just the general theory known as lambda CDM. Or did it? Hello wonderful person, this is Anton, and so today we're going to be discussing this relatively new study and a relatively new analysis, which kind of actually includes several studies, which once and for all confirms that it doesn't seem to be weird. There doesn't seem to be anything strange here, and the previous announcements that some of these galaxies were a little bit too massive and a little bit too developed might have been a little bit premature. In other words, no theory is violated, Big Bang has not been disproven or proven wrong, and these galaxies are technically just maybe a little bit different, but not weird at all. And so let's discuss these details, and let's actually start with where these predictions and these initial announcements came from. I mean, even before these galaxies were discovered. And so generally, when it comes to really old galaxies, and specifically the evolution of these ancient galaxies, pretty much all of the modern assumptions are actually based on various simulations and various mathematical predictions, which normally rely on supercomputers to try to recreate some of these galaxies and to essentially try to recreate what we believe might have happened billions of years ago. And though approximately a decade ago this was actually not very easy to achieve, because of advances in modern computing and because of the overall decrease in prices, it's now actually possible to create relatively accurate models and relatively accurate computer simulations. Not super accurate, but way more accurate than before. And relatively recently there was at least one paper, the one that you can find right here, that essentially tried to look at some of these simulations we usually use to see if these observations from the James Webb were actually violating any of the predictions from some of these simulations. And by the way, in case you're wondering, the biggest simulations are listed here. We have Eagle, Illustrious, TNG-100, Simba, Obelisk, Romulus-C, and Jades in this case represents the observations from the James Webb. And as you can kind of see from this graph, for the most part things do not really deviate too much. So there is maybe some discrepancy, but the overall alignment is not too different. But there is a problem here. These simulations, such as Illustrious that you see right here, are generally not really sufficient to truly show us what happened early on and to accurately simulate the formation of all of these early galaxies. They're accurate enough for some of the more advanced galaxies, such as the Milky Way, and they're accurate enough to show us the progression for billions of years. But when it comes to really early galaxies, especially 13 to 14 billion years ago, due to limitations in resolution, things here are just not as accurate as they should be. But it was the results from these simulations and from the analysis produced by various papers that was used as a comparison to all of these discoveries from the James Webb, even though it might not work really well with more distant galaxies, especially galaxies at the redshift of 10 or higher, such as many of these galaxies you see right here. Nevertheless, once the announcements were made, quite a lot of naysayers of ideas like the Big Bang Theory, or even the ideas behind dark matter and dark energy, started to use these examples from the James Webb as the proof that, first of all, dark matter, dark energy probably doesn't exist, second of all, Big Bang probably didn't happen either. Now these were really big claims, and this was of course something that a lot of scientists were trying to avoid, but titles like this were pretty much everywhere. And unfortunately this didn't really help the situation, especially because this was completely wrong and was never implied from any of the studies. And one of the previous videos from a few months ago goes through a lot of details of why this is completely incorrect. The discoveries were still there and the galaxies were still found, and some were a little bit too massive compared to what the scientists expected. And what's interesting is that some of these galaxies even had really high stellar masses or even a lot of star formation, more than the scientists predicted originally. But once again, these predictions, for the most part, were based on somewhat outdated modeling, and definitely something that's not very precise and not as accurate as it should be. Although, as you can see from this image again, even these models did not really show us anything unusual. But now we have a new paper that almost definitively proves that nothing weird definitely happened here by essentially analyzing the most detailed model that we currently have. The model known as Renaissance, the simulation that produces an extremely high resolution early universe models showing us how galaxies formed early on, and even modeling galaxies as small as 10,000 solar masses or as big as tens of millions of solar masses, and doing so with a lot of accuracy and a lot of detail. All of this is done using Blue Water's sustained petascale computing supercomputer at the University of Illinois. And so in this case, the scientists used the Renaissance model, comparing it to 6 galaxies from the James Webb Discoveries with a redshift of 10 or higher, located when the universe was only a few hundred million years old. In the end, showing that all of these massive galaxies seem to be totally consistent with the models from Renaissance, with none of them breaking any rules. As a matter of fact, it seems to be in perfect agreement with models. And that includes models of dark matter, dark energy, and of course the idea of the Big Bang. And because this is the most accurate simulation we have right now, at the moment there's really no suggestion anywhere that for some reason physics were broken or something doesn't add up. But it does show us something. It shows us that some of these simulations we've used previously, such as Illustrious project that you see right here, are just not sufficient to fully explain how galaxies formed early on. Which is maybe not the news some people wanted to hear, but it's exactly the news that all of the scientists wanted to hear, because otherwise it would be very difficult to explain things. And more importantly, it doesn't disprove the Big Bang, it doesn't disprove dark matter or dark energy, but does suggest we have to be super careful when using some of the older models and older simulations when trying to explain modern observations or specifically explanations from the James Webb. Or at least that's what we think for now, and that's what all of these studies are showing us. We're obviously going to have even more data coming from the James Webb in the next few months, and we're obviously going to have better simulations in the next few years. So things might change. At the moment though, as of May of 2023, it doesn't look like anything was broken, it does not look like any of the physical models of the universe are incorrect, and it looks like the Big Bang theory is correct after all. In just the last few months, James Webb Space Telescope has already made a lot of incredible discoveries, and today we're going to be discussing yet another one that once again currently does not make a lot of sense. A discovery of a distant galaxy in the early universe that possesses a feature that is normally believed to exist only in much older galaxies. A distant galaxy containing a galactic bar. Something that previous theories suggested should not exist so early, yet the new observations from the James Webb suggest otherwise. And so, hello wonderful person, this is Anton. Let's discuss this unusual barred galaxy that was recently discovered, talk about what's probably happening here, but also discuss these unusual barred features and what they actually mean for galactic formation and galactic evolution. And also obviously discuss if this means that, once again, something is broken with our physical understanding of the universe, or if there's some kind of a much simpler explanation. And let's actually begin with what exactly these features are. And based on a lot of observations and statistical analysis of galaxies near us, today we know that most bars seem to form inside spiral galaxies. As a matter of fact, up to 2/3 of all spiral galaxies seem to contain a bar. And that of course includes our own galaxy, the Milky Way. And today it's generally understood that a galactic bar represents a kind of a maturation period. And so it's a sign that the galaxy has reached full maturity and has not experienced major collisions or major interruptions for a very long time. And this becomes particularly apparent if looking at much more distant galaxies, especially the ones billions of light years away. A lot of distant redshifted galaxies that appear spiral will actually very rarely contain a galactic bar. As a matter of fact, only 20% of distant galaxies contain one, compared to about 70% of the ones near us. Implying of course that it's something that seems to develop with time, and something that becomes very common in the much older universe, or basically relatively close to us. And today we know that this directly relates to the way galaxies evolved based on various statistical observations. Galactic bars have now been described as several different types, from the most developed ones to ones that are barely visible at all or are still developing as the galaxy is stabilizing its shape, with some galaxies, such as this lenticular galaxy NGC 2787, sort of serving as a kind of a first step in this evolution. Here there are no spiral arms, and the galactic bar is still really tiny, still growing in size. But I guess one important question is, how exactly does all of this form? Well, based on various simulations, which I'll show you right now, we know that all of this occurs naturally as a density wave moving away from the center starts to affect the orbits of different stars close to it. And so it's actually directly connected to the natural instability of a stellar disk, and is also a way for the galaxy to transfer some of its angular momentum into something a little bit more stable. But we also know that these are not permanent objects. They can actually exist for up to 2 billion years, but will eventually dissolve, very likely regenerating again sometimes later. With this oscillation cycle from spiral galaxy to barred spiral galaxy and back to spiral galaxy, very likely happening many times in most galaxies like the Milky Way. And at the same time, they also have a major effect on the galaxy itself, especially the center. They seem to funnel a lot of gas located in the spiral arms toward the galactic center, very likely fueling a major starburst activity and a lot of star formation that we know exists in the Milky Way as well. You can learn more about this in one of the videos about the Milky Way in the description. Which is also why quite a lot of very beautiful spiral galaxies, such as M83 or the Southern Pinwheel Galaxy, tend to actually have active galactic nuclei right in the center. All of this gas, funneled by the bar, ends up powering the central black hole. Although here I guess a small side note, even though the Milky Way has a bar as well, it's unclear why the central black hole in our galaxy is quite timid in comparison and is also not very massive at all. These black holes are way more massive, and also obviously more active. But either way, when it comes to these galactic bars, it was previously expected that all of this very likely takes at least a few billion years. So basically, to form the first galactic bar, the galaxy would have to stabilize for at least a few billion years, very likely only appearing 8 billion years ago. But the recent discoveries from the James Webb Space Telescope suggest otherwise. Here we have a galaxy known as Ceres 2112 that existed 11.5 billion years ago, or basically when the universe was only 2 billion years old. And though obviously the observations here are somewhat limited and don't even show us a spiral galaxy, they do show us some kind of a thickened bar through the center of some sort of a galaxy, with the assumption being that this is maybe, probably, most likely, a spiral galaxy, with the shape also suggesting that it's quite developed for its age. As a matter of fact, all ancient galaxies containing bars are pretty much always spiral, and so this galaxy is also most likely spiral as well. We just don't see the shape because it's kind of far away. And all of this implies that galaxies once again matured much faster than we believed, and galactic bars very likely formed much quicker as well. Or maybe it means that the universe is older, much older. But that's unlikely, and I'll explain to you in a second why. In terms of this bar though, because we know bars exert so much influence on various galaxies, this is a really important discovery. As a matter of fact, the scientists behind this paper currently suggest that this is exactly what the Milky Way looked like approximately 11.5 billion years ago. Here they suggest that this is a progenitor to the Milky Way-like galaxy because the structure, the mass, and even to some extent the shape represents what the scientists always believed Milky Way potentially looked like when it was just forming in the beginning, with the only difference being that it also has the bar. And this suggests that bars potentially only take a few 100 million years to form, not a few billion. It also suggests, as this galaxy matures and becomes more developed, it might at some point acquire an active galactic nucleus, thus becoming even more visible from a distance. But because this is a brand new discovery, at this point nobody knows exactly what's happening here, or more specifically, what this galaxy will become. But does this discovery break the current models of the universe? Well, that's unlikely because of other discoveries from very similar studies using extremely similar data. And specifically, one of the other discoveries, looking at other massive galaxies far away that were previously suggested to also break current models. Here this was actually reported a few months ago from one of the most iconic images coming from the James Webb. And so here the scientists whose paper you can find in the description recalculated everything by measuring what's known as the Balmer break, in essence confirming that a lot of these galaxies were much closer to us, and the assumption that these massive galaxies existed early on was very likely somewhat incorrect. They did exist, just much later. Moreover, another study from just a few days ago made another incredible discovery of the second and the fourth most distant galaxy ever observed. These galaxies existed when the universe was only 330 million years old, with a redshift of 12 and 13. In terms of the distances here, these are about 33 billion light years away from us, with all of this located inside the cluster known as Abell 2744 or the Pandora cluster. And surprisingly, these are actually much larger than previous galaxies discovered so early on, so large as a matter of fact that they don't just appear as tiny dots, they appear somewhat elongated with somewhat irregular shapes. Yet, in terms of the actual size, even though these are 6 times larger than previous discoveries, they're only about 2,000 light years across, at least 50 times smaller than a typical spiral galaxy close to us. So this once again confirms that all of these early discoveries and all of these early galaxies are actually poorly developed, very small, and are very likely going through some really turbulent development, as expected from current models of physics. No actual giant galaxy has been found in any of the images from the early universe, and so none of these galaxies are giant or massive or in any way unusual at all. Nevertheless though, this is a really exciting discovery because here, these are 2 galaxies out of approximately 60,000 in this entire image. So yeah, quite a serendipitous discovery. But once again, presenting a mystery in terms of their shape. It's unclear why they're so different and what happened to these galaxies to make them appear the way they appear. But in terms of barred spiral galaxies, and more specifically, what happens inside bars and how they influence galaxies, at the moment, James Webb Space Telescope has been actively trying to figure out all of this by mapping several galaxies close to us. We've discussed some of these images before, but it's a long-term project that's essentially been trying to assess what happens inside these galaxies by trying to look through all of this dust in the middle in order to uncover all of the star formation processes and how all of this is affected by the bar and the structure of the galaxy. These particular studies are still in their infancy and no discoveries have been made just yet, but because of James Webb's ability to see through the dust, it's quite likely that in the next few years we'll have some answers about the bars, how they form, how they influence galaxies, and how they can actually grow so fast when the galaxy is still very young and still developing. So in the next few days from when I'm making this video, we're going to be getting even more images from the Orion Nebula taken by the James Webb Space Telescope. And specifically there are going to be some images of the iconic baby stars, including images involving very unusual phenomena and very unusual structures that we're still trying to understand even today, such as the unusual object you see right here. We've actually discussed this at least once on the channel before, but these unusual formations are actually some of the most important objects James Webb is trying to study. These are known as Herbig Haro objects, and for the most part they all sort of look the same. They resemble long nebula with somewhat symmetrical shapes on both sides. And we've briefly discussed one of these objects, released by the James Webb relatively recently, because in this image there was actually an unusual formation resembling a question mark, accidentally found inside the image, whose origin is still not understood. But we didn't really get to discuss this object itself, and of course similar formations, which is exactly what I wanted to do today for one simple reason. More images are going to be released very soon, and so it's important to understand what this all means. And so, hello wonderful person, this is Anton, and in the next few days we're going to be getting the image of this, Herbig Haro 212, yet another one of these objects, somewhat mysterious objects, that the scientists are trying to understand a little bit better. And the thing is, when these objects were originally discovered, for the most part they basically resembled unusual nebular clouds with somewhat unusual features inside, and also very often located in other popular nebula such as the Orion Nebula, but initially discovered by two scientists, Dr. Herbig and Dr. Haro. Here's actually the first object that they found. This is known as the HH1 and 2, mostly because they thought this is two objects, even though technically this is actually just one single object. Nevertheless, there are two clouds. And while over the years, many such objects have been discovered in the Milky Way with a lot of different properties and somewhat different shapes. Always long, always symmetrical, and usually associated with various molecular clouds. But it wasn't until the observations from this object, HH47, that the initial mystery was kind of finally solved. The scientists discovered something else right in the middle, right between all of the nebula. A protoplanetary disk. Essentially, as you can probably guess, because all of these objects were located in molecular clouds, it became pretty clear that these are forming stars. Here's another one known as HH30. And here's the image of one of these disks, taken by the ALMA telescope, inside the object HH212. The same object that's going to be revealed by the James Webb really soon. And so in that sense, it didn't take long to figure out that this is basically baby stars. But not like any baby stars. Super young baby stars. Essentially not even stars yet. These are objects that are only thousands of years old, that are slowly moving closer and closer to the center, growing the central object larger and larger, and essentially forming a protostar. Even though right now it's most likely just a very thick, cloudy region with something massive in the middle accumulating a lot of gas. And all of this becomes particularly obvious if you look at these objects with the James Webb in the infrared light. So this is the object HH4647 that sort of looks like this in visible light. Here you don't really see the star or the central region, but it becomes super obvious and super apparent if you look at it in the infrared, which is exactly why the James Webb has become the primary telescope to study these objects. Because of the dusty regions, it's almost impossible to see anything here, as the dust generally covers a lot of optical light. But the infrared goes through the dust, revealing absolutely everything. And so various researchers studying the evolution of stars and specifically focusing on baby stars have been actively requesting more time on the James Webb to take more of these pictures. And so this is what we get next, with the previous object being HH211 that you see right here and HH212 being the next. And so first, what exactly is going on here? Well, as you can see, it's not really difficult to understand. We have a protostar somewhere in the middle, in this case almost invisible, and we of course have a bunch of other objects, including a newly evolved protostar, because all of this is once again in the Orion Nebula. But unlike other objects in the Orion Nebula, in this case HH212 is really young, very likely less than 50,000 years old. And we can actually measure the age of these objects by doing one simple thing, by essentially looking at these objects for many years and then measuring the velocity of the nebula as it spreads across. And in this case, almost every time they move at very fast velocities, usually at least several hundred kilometers per second. And so here, after about 20 years of observations, it becomes pretty obvious how much the gas here moved away from the center, allowing the researchers to figure out the age of the object, what's most likely happening in the middle, and what sort of a star it might form eventually. Although for the most part, for many of these questions, the answers are usually still a little bit uncertain. But I guess more importantly, this is very likely how the solar system began as well. As a matter of fact, it looks like most if not all stars begin this way. And here's actually one mystery. Turns out that the much more powerful emissions from these HH objects usually occur in binary systems, or I guess growing binary systems. And it turns out that about 80% of all of these objects are very likely binary. But based on observations from Gaia telescope, we know that the majority of stars don't seem to be binary and instead seem to be single, which implies that maybe there is some kind of a transition between a young star and a mature star, where essentially one of the stars escapes and creates its own star system, although I guess more realistically, this is just one of those mysteries the researchers are trying to solve. Why is it that there are 80% of potentially binary baby stars that then end up mostly becoming singular stars? And so this is hopefully what the James Webb is going to help us a little bit more. But I guess the initial question to answer here is, what's really happening on the inside? Why do we see these structures, and why is it so common everywhere? Today it's believed there are approximately 150,000 such objects in the Milky Way. Most are too far for us to see, but statistically that's what's believed based on the observations near us. And so this is actually a universal mechanism that doesn't just apply to stars. It applies to galaxies, it applies to anything that starts spinning. As the molecular gas starts to accumulate into tighter and tighter clouds, and starts to slowly create some kind of an accretion disk inside the protoplanetary system, things closer to the center are going to start rotating much faster. But the thing is, if things rotate too fast, nothing will actually condense in the middle, and the entire object is just going to fly apart completely. And so something has to get rid of some of this angular momentum. And though it's not entirely clear how exactly all of this works, the overall process potentially looks something like this. Just like with black holes, the accretion disk contains quite a lot of ionized particles, which start forming powerful magnetic lines around this object. And because things here are also spinning, these magnetic lines will start getting entangled, capturing some of the material from the disk inside these magnetic fields, and then throwing everything out through two poles formed away from the center. In this case, it might involve magnetic snapping, where basically the magnetic lines snap, releasing all of the material at once, or it might involve some other mechanism. Although because we tend to see these objects moving away as large chunks as if there was a major emission, the magnetic snapping right now is most likely the best explanation. And over time this produces these objects that are usually at least 3 to 10 light years in length, that are basically formed as a result of these very powerful fast-moving emissions interacting with all of the gas inside the molecular cloud. And so it's basically the very fast-moving particles striking the cloud that then start producing these visible observations. With all of this gas carrying away not just the angular momentum from the central accretion disk, but also taking with it a lot of different elements from the cloud, which then, due to their extremely fast velocities, initiate complex chemical reactions. And so in essence, this also serves as an extremely important chemical enrichment process, which dramatically changes the molecular makeup of the entire cloud, with a lot of this material potentially used in other stars nearby, or possibly in future stars forming in this region. Although for the most part, about 99% of everything here is just hydrogen and helium. But the remaining 1% of stuff does actually produce relatively complex molecules. For example, things like metal hydrides, sometimes seen in various nebula, are believed to be produced in these very unusual shock-induced reactions. which very likely starts when some of these unusual clouds move at slightly different velocities, with the faster cloud catching up with the slower cloud, smacking into it, initiating all of these chemical reactions. And so a huge amount of various molecules have been actually seen inside these clouds, suggesting that a lot of different baby stars as they formed very likely influenced the chemical composition of future stars nearby. But all of this only lasts for a few thousand years, because at some point the star matures, stops creating so many powerful emissions, and eventually starts forming planets. Although intriguingly, in terms of the amount of material lost as the star grows, it's actually relatively significant. Anywhere from 1 to 10% of the solar mass seems to be lost every single year inside these jets. And though eventually the star will actually grow much larger and much more massive, 10% is still a significant loss. Although in terms of the actual mass, it usually only amounts to like 1/1,000,000th of a solar mass per year. Nevertheless, still quite a powerful and obviously quite an important process that seems to be universal pretty much everywhere. But I guess what I'm really curious about is what exactly are the scientists going to discover here? This is the next image that's going to be released, but we don't really have any scientific data just yet. Nevertheless, maybe in the next few weeks or in the next few months, future studies might provide additional answers about how all of this works and what exactly happens here as these very unusual objects evolve over time. Hello wonderful person, this is Anton, and in one of the recent videos covering the discoveries from the James Webb Space Telescope, I discussed an unusual discovery of what the scientists refer to as red spiral galaxies. Galaxies that essentially resemble the Milky Way, but seem to be a lot redder, or sometimes even entirely red, in color. And not red because of the redshift or because they're really far away, but actually red completely naturally. Which, when it comes to our understanding of galactic evolution and how we believe galaxies form, does present a bit of a mystery. I would even go as far as to say this is one of the bigger mysteries from the James Webb Space Telescope discovered so far. And so in this video I wanted to talk a little bit more about what these galaxies are, why they're so unusual, what they represent, and why this is maybe a pretty big mystery that the scientists are going to be scratching their heads about for a pretty long time. And I guess let's start with the basics. So when it comes to galactic morphology, or basically the shapes of galaxies, you can generally, very roughly, divide them into two. We have the blue galaxies, which are very often spiral in shape, although in many cases don't have any shape at all and are referred to as irregular galaxies, or are somewhat reddish or orangish in color. And very often these will be elliptical galaxies, or essentially galaxies that are somewhat symmetrical and somewhat spherical in shape, with the color itself being the result of the star formation inside the galaxy. A typical elliptical galaxy like IC 1101 right here, the largest, most massive galaxy discovered, is basically reddish and really old. Or the stars here are somewhat old, with very few new stars being created. But spiral galaxies like the Cartwheel galaxy that you see right here possess a lot of young stars and are blue in color. And this is essentially a basic fact about them. And so when the galaxies are born and when they're still being developed, or when they actually go through a lot of collisions and acquire a lot of new gas, such as NGC 1427 right here, they turn blue because of various star-forming activity, and eventually turn a little bit more red as a lot of the galactic gas escapes, and eventually strips the galaxy from the material making new stars. Although in this case, the stripping effect can actually happen for many other reasons. For example, we know that very powerful supermassive black holes that form quasars very often play a very important role in stripping galaxies of a lot of gas inside, and thus preventing star formation as well. Although here the feedback mechanism is actually really complicated. Sometimes it can do the opposite, sometimes it can actually encourage star formation. But the main point is this: as galaxies age, and as they lose a lot of the material inside, they slowly become a little bit more red and acquire a much older stellar population compared to younger blue galaxies. And so, for example, the famous M87 galaxy that you see right here is one of these red galaxies. In this case, it's an elliptical red galaxy. Whereas the nearby Andromeda is a blue galaxy, which obviously suggests that it has a lot of younger stars and still has quite a lot of star formation. And so by studying the morphology or the shape of a typical galaxy, it becomes possible to study the process of galactic formation and of course galactic evolution. But there obviously are some exceptions. And here are some of these exceptions discovered by a very famous survey known as the Galaxy Zoo. In the last few years, it's been capturing more and more of these red spiral galaxies, or basically spiral galaxies that resemble a typical elliptical galaxy in color, revealing that they also exist as well. So not all spiral galaxies are going to be blue in color. And for the most part, in the modern universe, basically within a few billion light years away from us, on average the scientists seem to find 2 out of every 100. Or essentially 2% of all spiral galaxies seem to be red in color, some more red than others. I'll talk a little bit more about the importance of their properties in a few minutes, but let's actually talk about the important discovery from the James Webb. This is of course coming from the super famous SMACS J0723, one of the first images released by the James Webb. And here there was a really weird surprise, discovered billions of light years away from us. Extremely red spiral galaxies existing during the period of time known as the cosmic noon. This was around 10 billion years ago, and according to the modern observations, it actually represented the most active period of star formation, or essentially the vast majority of star formation happened around this time. So basically we expect a lot of blue galaxies during this period. This has been observed from a lot of different objects, and quite a few stars created during this time were discovered as well. But remember I mentioned that red galaxies represent pretty much the opposite, a very low star formation. And it just so happens that statistically, because here the scientists only took a look at a very small sample of galaxies during the cosmic noon and actually discovered quite a few of these red spiral galaxies, it implies that they were much more common back then than they are today. And that is really strange, it actually doesn't add up at all. It means that for some reason, back in the days, 10 billion years ago, there were a lot more spiral galaxies, which by the way are very complex to begin with, that did not form any stars. Yet suddenly, 10 billion years later, the situation reversed. Now there are a lot of star-forming spiral galaxies and very few red galaxies. And by the way, on top of this, these were also some of the farthest spiral galaxies ever discovered. So this was a huge surprise and a huge mystery. Not only was the mystery of how exactly were these spirals created back in the days, but also why exactly were they not forming any stars anymore. And interestingly, these galaxies were originally detected by the Hubble and the Spitzer telescope, but as you can see, the resolution here was very low. These galaxies were barely visible. But thanks to the James Webb, we can finally see what's happening here. And so RS13 and RS14 represent the most extremely red galaxies ever found. Even much redder than anything we have in the local universe. Here's a pretty good visual comparison between a typical red galaxy in the modern universe and a typical blue spiral galaxy. But more importantly, it was definitively confirmed that at least one of these galaxies is essentially passive. It practically has no star formation at all. Other galaxies maybe have red color for some other reasons, but RS14 is definitely passive. Yet it existed during the most active period of star formation. So yeah, what exactly is going on? Well, for now, one of the potential explanations is really in regards to the amount of dust present within the galaxies. There's still a chance that maybe they're extra red because of a huge amount of dust present inside the galaxy, causing the effect known as dust reddening, which would potentially explain what's going on. But even if that's the case, there's another problem here. This graph right here kind of shows you the overall decrease in numbers of well-established spiral galaxies as you look back in time. Specifically, galaxies containing what's known as a bar structure. These galactic bars are believed to be formed only in galaxies that have established themselves for a pretty long period of time. In other words, they have not experienced any major galactic collisions and have not been disturbed for billions of years. And because there are less collisions today than there were billions of years ago, we expect more galaxies to be well established and more galaxies to contain spiral bars. Which means that the observations kind of prove the theory here as well. This is going as far back as approximately 8 billion years. But intriguingly, if you actually look at some of these galaxies, specifically RS14, it almost looks like it does possess a bar as well, as if it was a mature, settled galaxy. Now it existed around the time the universe was about 4 to 5 billion years old, so there's maybe a slight chance that it did actually have enough time to mature and become a barred spiral galaxy, but there's also maybe another explanation here as well. This galaxy could be extremely massive. Other discoveries, looking at various spiral galaxies, generally found that supermassive spiral galaxies tend to acquire these bars much quicker than anything else. And more intriguingly, about half of all red spiral galaxies seem to contain bars as well, whereas only about 14% of blue galaxies like the Milky Way contain these galactic bars. with the implication being red galaxies and more massive red galaxies seem to be well settled and also will most likely contain a galactic bar, with many other studies establishing that overall it seems that the mass seems to matter most. More massive spiral galaxies are more likely to become red much quicker and are also more likely to acquire bar structures in the middle, which possibly implies that these are extremely massive spiral galaxies. And if so, would also create a problem of, okay, why are they so massive? And more importantly, why did they stop forming stars? To become so red, they would probably not have to have any star formation for at least 1 billion years. Now it's definitely possible because the universe was already 4 to 5 billion years old, but why? This was the most active period in the universe. Why did these galaxies stop forming them? And while some of the other answers seem to come from other studies that discovered that a very large proportion of red spirals seem to be what's known as liners, low ionization nuclear emission line region. Or in more simpler terms, they do contain a somewhat active center where there is a supermassive black hole creating quite a lot of wind, but this wind by itself could potentially blow out a lot of gas from within the galaxy, thus stopping star formation. The Sombrero galaxy here is a pretty good example. And so maybe these are just spiral galaxies with a somewhat active central region, producing just the right amount of wind to essentially starve the galaxy of any star-forming gas, and thus eventually stop the star formation. Intriguingly, there's also a bit of a correlation between a relatively large bar and the prevention of star formation in a galaxy containing such bar. Or at least that's the case for a lot of red spirals. About 70% of them seem to contain relatively large bars, and many of them have stopped producing stars as well. But the actual process of galactic starvation, or basically expulsion of the gas, probably happens because of what's known as bar instability. Or basically when the bar, that's actually quite gravitationally potent and produces a lot of effects in the galaxy, for some reason becomes a little bit more unstable and possibly throws off a lot of gas to the outside. And so in this case, as the bar becomes more unstable, it causes some of the gas to eventually start leaving the galaxy, reducing the star formation. At least these are some of the modern explanations for what we're observing in these galaxies, and for why we're observing no star formation in a lot of these barred spiral galaxies. But here's the thing, we still have no idea why so many were discovered 8 to 10 billion years ago, in this image from the James Webb. Now here we're talking about proportionally speaking. In terms of the actual number, it was not that many, but it still doesn't really currently make a lot of sense. It definitely suggests that the actual proportion of these galaxies during this period of time was much higher than 2% that we usually find around ourselves today. And so even though not a lot of studies have been talking about this so far, this is a pretty big discovery. This is actually a huge discovery, a mystery that currently has no actual resolution. But the only possible answer is that, once again, we just don't understand how galaxies form and evolve, and we still are missing something really crucial when it comes to the formation of spiral galaxies. Maybe these galaxies are really not formed the way we think they're formed, or maybe something else needs to happen inside these galaxies for them to acquire certain properties we detect today. Although I guess important to mention here, it definitely does not validate any of the modern theories such as the Big Bang theory. That still stands, but it does create a bit of a problem when it comes to galactic evolution. Hello wonderful person, this is Anton, and not so long ago we've talked about various galactic discoveries coming from the iconic James Webb Space Telescope. Discoveries made by this beautiful telescope in just a few months in early to mid 2023. But naturally, as soon as I finished editing the video, yet another discovery was made of yet another somewhat exciting, unusual galaxy. Although I guess calling it unusual maybe is not fair. Very usual, typical galaxy. As typical as it gets. And so in this particular video, I wanted to focus on this galaxy, currently referred to as JD1, that in some sense is maybe even a much more important discovery than any of the other galaxies previously seen by the James Webb. Despite being super average, not really anything special, and more importantly, even being barely visible. And so let's discuss this in a little bit more detail. But first, exactly how was this found and where is it located? Well, this barely visible galaxy is inside of this very beautiful cluster you see right here. This is known as the Pandora cluster, and it's a really intriguing object because it seems to be a pileup of 4 smaller galactic clusters that must have collided 350 million years ago. And as a result of this collision, we get to observe a lot of gravitational interactions along with various emissions, including various X-rays visible in red in this image. And though most of the galaxies that are visible seem to represent only 5% of mass, it's really the interaction of things like dark matter and a lot of really hot gas that produces most of the gravitational effects. And because of these somewhat unusual observations and somewhat unusual effects that are produced inside of this cluster, the scientists now refer to it as the Pandora's cluster. The cluster that unleashed a lot of different effects as a result of a collision. But then, back in 2014, when the Hubble telescope was looking at this cluster, it accidentally discovered an unusual patch that you see right here. A patch that resembled something really far away, but nobody really could tell exactly what this was. The scientists assumed this to be a galaxy, with a relatively high redshift, but it was impossible until now to precisely determine what exactly it was. In other words, this was discovered almost 10 years ago, but there was just not enough data available to do any kind of analysis. And that's of course, until now, until new observations with the James Webb Space Telescope. The telescope whose main job is to analyze galaxies like this one. And so by observing this once again in infrared light, and by looking at this gravitationally lensed image from two different perspectives, the scientists were able to definitively confirm the existence of this very faint galaxy. A galaxy that was very likely in existence when the universe was only about 480 million years old, and most importantly, represents the faintest galaxy discovered so far. It's barely visible at all. And the only reason we're even able to see it is because of that Pandora galactic cluster that amplified its luminosity by approximately 13 times. But because this is James Webb, it was now able to see things in different frequencies, creating spectroscopy for this galaxy, which of course means that we can determine the exact distance, placing it right at the beginning of reionization period. The period that the scientists believe is responsible for basically making the universe somewhat opaque to quite a lot of different light coming from the stars. But since this particular galaxy doesn't seem to be particularly exciting in any other way other than being somewhat dim, why are we even talking about this? Well, it's that reionization period, which by the way is one of the main mysteries the James Webb is trying to solve, that could potentially be explained by this discovery. So here's what I mean by this. This galaxy has a very low stellar mass. It also has relatively low metallicity and is about 5% as bright as a typical modern galaxy. It's also really small, at possibly about 500 light years in size. This image also shows us that it contains at least 3 separate star clusters, where quite a lot of activity is being generated through the production of new stars. And normally, this galaxy would be completely invisible to us, except that it found itself in just the right orientation and passed in just the right way in front of us in order to be magnified just enough for the light to be visible by the James Webb. If it wasn't for the gravitational lens, it would also be invisible to us even now, even to the James Webb Space Telescope. So this discovery was basically completely accidental. But the scientists behind this paper, and actually a lot of scientists studying James Webb images and a lot of other images, currently very strongly believe that this represents most of the galaxies that must have existed during this period of time, and more importantly, must have been responsible for reionizing the entire universe. Or essentially changing the universe from being somewhat opaque, where the hydrogen gas doesn't allow a lot of powerful light to go through, to changing hydrogen into ionized hydrogen, suddenly making the universe transparent to all of the light. And it was the presence of this hydrogen previously that sort of prevents us from seeing quite a lot of things in the early universe. Or just to rephrase this somewhat modest looking galaxy is most likely the typical representative of most galaxies that used to exist back in the days. Whereas a lot of these other galaxies we discussed previously, the ones discovered by James Webb previously, and the ones that generated a lot of buzz, are actually the exception to the rule. These particular galaxies are very likely much brighter, much more massive, and also much more rare compared to what we expect to find in that particular period of time, making these exceptions to the rule, and this a typical representative of the reionization period. These galaxies were most likely all over the place. They were also reionizing hydrogen across the entire universe, but because of that neutral hydrogen and because of their overall dimness, they're practically impossible to discover unless they're in just the right position in front of a very powerful gravitational lens that can then magnify their brightness. And since one of the major goals of astronomy, and specifically the James Webb itself, is to actually determine the types of galaxies responsible for reionization, in some sense, this galaxy might have just solved that mystery once and for all. Whereas a lot of these other galaxies we've discussed in the previous video are examples of very bright, very powerful, and somewhat rare galaxies that are most likely not the average typical galaxy during this time. In some sense, this would be very similar to like M87 or Messier 87, that's one of the more massive, brighter galaxies in the vicinity of the Milky Way, compared to a lot of smaller, less prominent galaxies located in the vicinity. So this is just a really bright, really powerful example that does not represent the norm. Which also means that these galaxies were probably not responsible for most of the reionization that was very likely done by much smaller, much more faint objects. And more importantly, because of the size and the overall luminosity, this also obviously suggests that the vast majority of galaxies 400 to 500 million years after the Big Bang were generally much smaller, contained a lot less stars, and were also relatively low in metallicity as expected by modern theories. With this somewhat serendipitous discovery, basically proving all of this once and for all. With this galaxy also serving as a reminder that there's always that observational bias that we have to deal with when trying to explain a lot of mysteries of, well, really everything in science. And so here, this galaxy possibly proves that most of the galaxies back in the days were exactly as the scientists always expected them to be. Smaller, containing a lot of active regions, like the 3 regions you see right here, and producing a lot of powerful stars, which then led to all of the gas around those galaxies changing into ionized hydrogen. So definitely a pretty cool discovery and a pretty cool analysis. But obviously just the first step in once and for all figuring out what happened in the early universe a few 100 million years after the Big Bang. Hello wonderful person, this is Anton, and back in 22, or I guess last year from when I'm making this video, you might remember that some of the initial releases from the James Webb Space Telescope were first followed by a lot of really funny memes, essentially comparing previous observations from the Hubble telescope with new observations from the James Webb, with new observations just being so much more detailed, and providing just so much more additional information. Now obviously these were just a joke, but the reality is that obviously the James Webb was making these incredible new observations that were previously completely unavailable to modern science. But during these early releases and these early observations, some of the most exciting discoveries came from the galactic cluster you see right here, referred to as SMACS J0723. This is the image from the James Webb, and here is the same image taken by the Hubble telescope. And of course what made this image exciting is the presence of a relatively powerful gravitational lens that allowed the scientists to suddenly see a lot of really distant galaxies that became dramatically magnified as their light passed in front of their gravitational lens. And in the process, the image contained 87 ultra-distant galaxies. Or I guess to be more correct, ultra-distant galactic candidates, with redshifts making them appear as they existed in possibly the first 500 million years of the existence of the universe. And that number, 87, was surprisingly high and way more than anyone expected. Moreover, some of these galaxies delivered really unexpected results. The redshift was really high. Prior to this, the galaxy with the highest redshift, or basically the farthest galaxy we knew, was GN-Z11, with a redshift of 11. But the discoveries from this particular image even suggested redshifts as high as 17 or maybe even higher, which actually would imply some galaxies already existed when the universe was only 240 million years old, which kind of suggested that large massive galaxies already existed pretty much within a few million years after the first stars formed. That kind of created a bit of a problem for modern cosmology, and I guess more importantly, created a lot of buzz about maybe the Big Bang theory being completely incorrect and the universe possibly being something entirely different from what the scientists believed for several decades since the Big Bang propositions. Which, if true of course, would create so many new problems because a lot of stuff would be impossible to explain with what's known as steady-state universe. But that's beside the point. The point here was that these galaxies appear to be really far, and they appear to be almost impossible. Or I guess more like very improbable. And so in this video, what I wanted to answer is one simple question. So what happened to these early discoveries? Were these candidates confirmed? And are these galaxies actually as far away as they were originally claimed to be? Or did new research prove this to be more or less incorrect? And so basically in this video, we're going to explore most of these early discoveries from the James Webb and what the scientists discovered in just the last few weeks, specifically the paper that you can find in the description, that goes through extremely detailed analysis using spectroscopy, which allows extremely precise measurements of galactic distances. But I guess first, a very important clarification. This particular image was just the first attempt, or I guess the first test, for what the scientists refer to as the deep field imagery. James Webb actually has at least 4 more active surveys that's already been discovering more galaxies. We have the GLASS survey that investigated the Lens Galactic cluster Abell 2744, more commonly known as the Pandora's cluster, the Cosmos Webb, the survey that represents the largest so far, and is most likely going to be announcing a lot of discoveries in the next few months, the James Webb Space Telescope Advanced Deep Extragalactic Survey, also known as JWST, whose discoveries we've discussed previously, and the Cosmic Evolution Early Release Science Survey, also known as CEERS, which technically was actually responsible for making these early observations and early discoveries, but there's still quite a lot of data left that's not been processed yet. And intriguingly, one of the discoveries from CEERS was this unusual galaxy you see right here, known as CEERS 93316. The apparent redshift for this galaxy was about 16.5, which would imply certain massive, very bright galaxies existed really early on, within about 250 million years after the Big Bang. But this was just a candidate galaxy. Its distance was only measured using redshift. Now this is really important because redshift by itself is more or less just a suggestion, or basically apparent redshift, which represents the redness of the galaxy assuming certain parameters. Just to give you a more visual perspective here, so let's just take a look at some of the more distant galaxies right here in Space Engine. You'll notice that some galaxies are sort of yellowish, some are kind of orange, but some appear relatively red. For example, there's a galaxy right there that seems to be really red, and it does appear to be somewhat Milky Way-ish in terms of shape. Now, it's quite possible that this is indeed a Milky Way-like galaxy that's been redshifted because of its extreme distance, but it's also possible that it's somewhat redshifted, or appears redshifted, because of, for example, presence of a lot of dust. Dust by itself can make certain things appear to be very red. On the other hand, in some distant galaxies, due to the presence of a lot of other gas in between the galaxy and us, you might actually just see certain types of light more often than other types. For example, maybe this galaxy does have a lot of blue light that's actually just blocked by something else. In other cases, when the galaxy stops star formation, it also generally tends to turn more red as well. So basically, just by itself the galaxy can appear to be red, and thus appear to be more redshifted. And so just the apparent redshift itself is unfortunately not enough to determine the exact distances, which was exactly the case for this galaxy. But there's one ability that the James Webb has that other telescopes, like Hubble, did not. Because it has such a wide infrared spectrum, it's able to see a variety of light coming from these extremely distant galaxies, which gives it a very important power. It's able to generate galactic spectra, or frequencies of light coming from distant galaxies, of various elements that we know usually exist in those galaxies. And usually in various galactic spectra, we do have certain breaks or certain peaks that can then serve as a direct measurement for various distances. The most famous one is what's known as Lyman break. It's essentially a sudden drop-off in certain frequencies because the light coming from these distant galaxies is unable to penetrate a lot of neutral hydrogen that's essentially in this early universe. And so the galaxies in those frequencies become more or less invisible, and this Lyman break is perfect for determining distances to some of these distant galaxies. And so not so long ago, we've discussed the official confirmation of some of these galaxies at certain distances. Right now, this one right here is the farthest we've discovered to date, with the distance confirmed to be at the redshift of 13.2. At this point, the universe was probably around 400 million years old. But this was just one confirmation. We obviously had 87 galaxies in total that needed to be confirmed, and so the scientists went through pretty much most of them, especially the ones that created the most buzz, by using very similar spectral analysis. And because this galaxy right here was probably the most exciting to test, let's obviously start with this. Yeah, it failed. It's not even close to being as far as initial claims. Instead of being at redshift of 16.4, it turned out to be only at the redshift of 4.9, or about 1 billion years after initial proposition, so the universe was already 1.2 billion years old. And because this is a bright galaxy, very enriched in various elements, also possessing very strong emission lines, and very likely containing a lot more mass than expected from an early galaxy, confirming that this is a more developed galaxy means that nothing here needs to be rewritten and no physics are broken. Interestingly, another similar galaxy was discovered by this survey at a very similar redshift of 4.9 that the scientists very early established was just masquerading as a high redshift galaxy, In reality, it just contained huge amounts of dust that made it look much more red than it should be. So both of these galaxies appear to be much closer. Then there was another discovery of a galaxy at a redshift of 14 that one of the scientists named after his daughter. It became known as the Macy's Galaxy. And turns out that, well, it's just not as far away. Still pretty far, just not as far. Its redshift was confirmed to be 11.4, which means that the universe was about 390 million years old. So maybe not as far as this galaxy, but much farther than other candidates. Currently, I believe it's like 5th farthest discovered so far. And further analysis of other galaxies established that most of them were much closer to us. 2 more existed when the universe was about 400 to 500 million years old, but the light from most of these candidates came from much older universe when it was already at least 600 million years old, with the actual confirmations being extremely accurate, using very specific spectroscopic analysis, as you can see in this image. Although intriguingly, at least a couple more galaxies were discovered at redshift of 4.9 in a very similar region, which actually does suggest that maybe this candidate is actually part of some kind of an early galactic cluster with all galaxies at a relatively similar distance. And that of course means that all of these galaxies discovered so far and all of these early candidates more or less fit directly into the picture of the universe we had before the James Webb captured all of these images. The universe very likely started with a few stars at first. These stars grew larger into larger clusters. This then formed into smaller galaxies. The galaxies developed and became bigger over time, and eventually formed into larger clusters. And based on the spectroscopic analysis of galaxies discovered so far, there does seem to be quite a lot of evidence for all of this happening as it expected to happen. Now maybe this can be seen as, I guess, confirmation bias, or basically scientists trying to confirm cosmology that they assumed existed, but I mean, the actual evidence is there as well. All of the redshifts for all of these galaxies so far do not seem to deviate from previous assumptions, with the galaxies themselves not also being particularly different either. And I guess more importantly, this right now being the definitive most distant galaxy we've discovered to date. But a lot of these discoveries also tell us a little bit more about the early universe that nobody really knew before. For example, there does seem to be a very rich population of different galaxies, and even galaxies containing globular clusters and very bright stars, that already existed in the universe in the first few 100 million years of its existence, with the numbers being much higher than originally predicted. The scientists have also discovered quite a lot of evolved bright galaxies, and some of them enriched in various elements, really early on as well, even when the universe was only about 350 million years old. This connects to other videos in the description where various explanations are kind of proposed, but it also connects to this really recent study from just a few days ago, where scientists proposed different types of models to try to explain how various galaxies were able to produce stars so quickly. And in essence, it's all really about the type of universe that it used to be back in the days. It was enriched in hydrogen and helium, it was also much more dense and contained much larger chunks of matter, and some stars could potentially grow to hundreds if not thousands of solar masses. But more importantly, these conditions led to extremely effective star formation, or starburst regions, that were able to exist so early on because there was just nothing stopping them from forming stars. For example, in the modern universe, there are things like black holes or even things like heated gas that normally stop star formation. This very likely was not the case early on, with the universe sort of allowing stars to form as much as they wanted. And that's what a lot of these early galaxies did, growing to large sizes very quickly. Which means that all of these images from the James Webb basically show us frames of various distant early galaxies kind of growing up and growing larger, more developed and more massive, but in a kind of a messy way, with huge amounts of very active regions, large amounts of activity, and lots of different gas regions where a lot of starburst happens all the time. And so none of these galaxies very likely looked like this at all. Most of them were more or less irregular in shape, with most of them not even falling into any specific category just yet. Actually, it would even be difficult to call them galaxies. They're sort of proto-galaxies that are developing and growing and changing their shapes all the time. But we also have to remember that this is just the beginning. All of this was discovered only after approximately 1 hour of total observations. It literally took James Webb 1 hour to find all of this. Now, as you might remember, Hubble telescope at some point spent approximately several months looking at the same spot, creating what's known as the ultra-deep field image. Once James Webb is able to do the same, we're going to discover an immense amount of new stuff, which means that in the next few years we're going to be making incredible discoveries that nobody can imagine right now. But chances are we're not going to be discovering something too major that's going to somehow break modern cosmology. At the moment, despite early assumptions and despite early observations, so far everything seems to be as it should be. The Big Bang seems to be real after all, the galactic formation seems to happen in a somewhat similar way to how we expected, with just maybe some caveats. One big caveat of course being that it seems to be more active and way more hectic, and I guess more importantly, no actual galaxy has been discovered existing before the universe was approximately 250 million years old, which by the way could maybe break certain theories. But this is still at the beginning, and there's still going to be so much new science that we're going to be talking about in some of the future videos. Hello wonderful person, this is Anton, and today we're going to be discussing a very recent announcement in regards to an extremely exciting star system known as TRAPPIST-1, but this time with the data coming from the James Webb Space Telescope. Because after months and months of analysis, the scientists finally have a confirmation. A confirmation in regards to one of the planets in the TRAPPIST-1 system, but in this case, maybe a somewhat negative or somewhat sad confirmation. It looks like at least one of these 7 planets, terrestrial planets, definitely does not have any atmosphere. And definitely seems to be a somewhat barren world, potentially very similar to Mercury, and very different from what the scientists were hoping to find. Very different from a terrestrial planet like Earth, or maybe at least like Venus. And so in this video, let's discuss some of the details of this discovery and what this means for the future of astronomy and the future discoveries coming from the James Webb, but also future discoveries coming from very similar planets. But I guess first, a very quick reminder. So a few years ago, one of the biggest announcements coming out of NASA was the discovery of a 7-planet star system approximately 40 light years away from us. But in this case, what made this particular star system really exciting is the fact that all of these planets seem to be terrestrial. Not so different from planet Earth in terms of mass, size, and density as well. And this implied one thing. It implied that at least some of these planets, maybe 1, 2, or even 3, could potentially host conditions necessary for life to evolve. Especially because at least 3 of these planets were located far enough from the star itself where technically liquid water could exist. The region we often refer to as the habitable zone. And since the original discovery, this particular star system became a prime candidate for trying to figure out whether these types of stars would actually be perfect for a potential discovery of a habitable Earth-like planet. Mostly because these types of stars, known as M-type stars, also known as red dwarfs, are extremely common in our galaxy. There are approximately 10 times more of these types of stars compared to G-type stars like our Sun. And on top of this, they also have a very high chance to have terrestrial planets, or essentially planets that are somewhat rocky, potentially Earth-sized, and thus have a high chance to have liquid water, with current analysis suggesting that the M-type stars are approximately twice as likely to contain terrestrial planets compared to even a Sun-like star, which basically means that about 95% of all Earth-sized rocky planets might be around a red dwarf. And since this particular red dwarf was discovered to have 7 planets in 7 different regions around the star, this literally became the prime candidate to try to understand all of this. But as of today, due to the lack of observations, most of the analysis so far has been kind of mathematical. If we go back a few years, there are actually videos on the channel almost contradicting themselves. Some studies suggested that there is a high chance to have liquid water, and thus a potentially high chance to even maybe have life of some sorts, but other studies would suggest the opposite. These planets would be kind of barren and potentially contain nothing. Not even the atmosphere. With both types of studies usually having quite a lot of mathematical evidence, but no observational evidence, mostly because the observational evidence was definitely lacking. Just to give you an example, here's exactly what these observations looked like back in 2018, when some of these planets were discovered. We're basically just looking at a tiny few pixels changing in brightness. And so to try to improve this, the star system was chosen as one of the first candidates for the James Webb Space Telescope. It actually did some initial observations back in June, July of 2022, and we also discussed some of the initial analysis and some of the initial discoveries in one of the previous videos from a few months ago. But it wasn't until this paper that you can find in the description below that we finally have a definitive confirmation of TRAPPIST-1b, the closest planet to the star that definitely receives more heat than Venus, but a lot less heat than Mercury. And since in the solar system, Venus contains an extremely thick atmosphere, yet Mercury contains none, trying to figure out what's happening around this planet was a somewhat important mystery to solve. Would it be more like Mercury, or would it be more like Venus? And because it was also much closer to the star, it was also a lot easier to study. Here's actually what one of the previous models of this planet looked like, with a lot of scientists assuming that it probably does have a very thick atmosphere like Venus. And if it had a thick atmosphere, it would then be possible to study the atmosphere directly by looking at all of the light passing in front of the atmosphere during these twilight periods that you see right here. But because this planet is about 40 times closer to the star than Mercury is to our Sun, whenever the star flares up, and it does so very often, this planet also receives a huge amount of charged particles, which in theory can actually strip this planet of pretty much everything on the surface, including any possibility for water or any atmosphere. As a matter of fact, some of these flares observed from similar stars can be hundreds of times more powerful than anything from our own Sun. And by being so close to the star, these planets risk losing everything from the surface, which seems to be precisely what the scientists have recently discovered. There's nothing here. This planet is completely barren, and seems to be extremely Mercury-like, with the surface temperature of about 230 degrees Celsius, which is slightly less than the day temperature on the surface of Mercury. And that's of course expected because Mercury does receive a little bit more illumination from the Sun. But despite this somewhat negative discovery, it's really the technique in this case that's particularly impressive, especially because now it can be applied to 6 other planets, including planets around other similar stars. And this technique is known as secondary eclipse light curve. It essentially involves 2 things: looking at starlight and then looking at starlight plus light from the planet. And that's of course because the planet itself also reflects some of the starlight, producing a little bit of its own illumination, and specifically because of the temperatures involved, it produces infrared light visible by the James Webb Space Telescope. And so by looking at this star in the mid-infrared frequencies, and by collecting just enough data to analyze this, the data analysis revealed that once in a while, the brightness changed by about 0.1%, or approximately 1/1000th of the total brightness of the star. And that's because the planet was also producing just a little bit of light visible by the James Webb, but only visible for about 9.7 minutes as the planet passed in just the right region. In other words, because of these extremely periodic changes in brightness, the only possible explanation was that it was caused by this particular planet as it reflected some of the light coming from the star, and it happened twice per orbit, with all of these observations only taking about 3 hours. And that's because a single orbit here is only about 36 hours. And so by subtracting the brightness of the star from the total brightness received, they were then able to determine the total brightness produced by the planet. And by combining this with several different models, they were then able to reproduce exactly what was observed. If there was some kind of an atmosphere here, the total heat would be much lower, mostly because the atmosphere tends to distribute the heat more evenly. But dark surface, no atmosphere, and no heat distribution produces almost exactly what was observed, almost definitively implying that this is a Mercury-like planet with no atmosphere, very dark surface, scorched by the star for billions of years, and potentially resembling Mercury almost 1-to-1. But because we know Mercury has quite a lot of water deposits in darker regions, and because this planet is assumed to be tidally locked to the star as well, we have absolutely no idea what's happening on the far side of this planet, the side that's never facing the star, and a site that could have, in theory, accumulated a lot of deposits, including potentially water ice. But that's not something we can determine anytime soon, with the only conclusive observations suggesting that there is definitely no planetary atmosphere, including CO2, oxygen, or any other element that could potentially produce greenhouse effects, with maybe only a very small exosphere present on the surface of this planet, with this exosphere being created by the interaction with the highly charged particles coming from the star, kind of similar to what Mercury has, and even a lot of other smaller objects that often contain no actual atmosphere. But for many scientists, none of this comes as a surprise. Previous observations from the Hubble telescope or from the infrared Spitzer telescope have pretty much discovered the same. There does not seem to be atmosphere around this planet, or actually around other planets as well. But whether other planets, including D, E, and F, the ones that are in the habitable zone, contain anything exciting, is not something we can answer just yet. Nevertheless, this is a major breakthrough for the ability of James Webb to directly gather information about terrestrial planets orbiting red dwarfs. And so this technique will very likely be applied to other planets very soon. But we're not going to know this until maybe later this year. The follow-up observations are only planned for June of 2023, And so at the moment we only have preliminary observations, but by the end of 2023, the James Webb might finally reveal exactly what's happening around the entire star system. Hello wonderful person, this is Anton, and we finally have new updates in regards to the iconic TRAPPIST-1 system that sort of looks like this, simulated in Space Engine. A very famous system announced by NASA in 2017 because, as we'll discover later, it contained 7 terrestrial planets. Planets very similar to Earth in mass and in density, with 4 of these planets potentially in the habitable zone of the star system. In essence, implying that we might have discovered a star system with at least several planets that could, hypothetically, host life, and maybe even be somewhat similar to planet Earth. At least that's what a lot of scientists hoped. But over the years, various observations from, for example, Haro telescope, and a lot of other observations from other telescopes, including mathematical calculations, started to produce somewhat contradictory results. On the one hand, many studies suggested that water could be possible here, with some of these planets potentially containing hospitable conditions, other studies proposing that some of these planets could be entirely different in terms of what's inside of the planets, but still contain rocky surface and maybe even water. And so for basically something like 6 to 7 years now, scientists have been eagerly waiting for new results from the James Webb Space Telescope, because one of its missions was actually to take a look at some of these planets and to try to see if at least we can maybe see some atmosphere, because by detecting atmospheres, we could then determine what's on the surface and what's even possibly inside. And so several investigations have been already proposed in the last few months, and at least one was officially finished just a few months ago. You can find that video in the description, but in a nutshell, it was the investigation of the closest planet, TRAPPIST-1b, the one that's expected to be the hottest and the one that's not in the habitable zone. Here, the scientists discovered that it doesn't seem to contain any significant atmosphere that will be made out of hydrogen or carbon dioxide. It would still have some kind of a thin atmosphere that's different, but nothing substantial to suggest that this planet was in any way atmospherically active. Instead, what the scientists discovered is something very similar to Mercury. Probably dark, very likely extremely hot on one side and possibly cold on the other side, but larger and more massive in size. So maybe not the most exciting discovery, but a very important discovery nevertheless. And so now we have news from the second planet, planet TRAPPIST-1c. But before that, let's briefly talk about the star system, just so that you remember exactly what it is. So, as so many other star systems in the Milky Way, this is what's known as a red dwarf. A star with a temperature of about 2500 Kelvin, which is much colder than the Sun, whose temperature is 5700 Kelvin. And it's a star system that's just under 41 light-years away from planet Earth. But because this is a very dim red dwarf, it's actually really difficult to find it, and it only produces a fraction of the Sun's starlight. Here's roughly how the Sun compares to this particular star, both in terms of color and in terms of brightness. And so it's definitely much smaller. It's actually very similar to Jupiter in size, even though it's about 9% of the solar mass. And because of this, the planets here orbit much closer compared to the solar system, and actually somewhat comparable to the moons around Jupiter. A single orbit here takes anywhere from 1.5 days to 19 days for the farthest planet. And because of this, just like around Jupiter, it's kind of assumed that a lot of these planets are very likely tidally locked, always facing with the same side toward the star, with one side being cold and one side possibly being hot. Now it's not certain that this is exactly what happens, but it's the most likely explanation. But compared to the solar system, this system is actually older. It's probably 7.6 billion years old, at least 3 billion years old older than planet Earth and than the Sun. And so because these planets had over 7 billion years to evolve, it's quite likely that they're actually very different from anything in the solar system. But more importantly, this makes it a perfect target to see what happens to terrestrial planets around various red dwarfs. Here we have 7 planets in different locations with different conditions, and so looking at all 7 of them might actually allow us to describe the majority of similar planets in the entire galaxy. Today we know that quite a lot of these red dwarfs, or M-type stars, seem to contain similar planets, and very often in very similar locations. So whatever happens here very likely happens elsewhere. But it's the planets D, E, F, and possibly G that are the most exciting because, as you can see from this image, they're basically in that region where the habitable zone could be located. The conditions necessary for possibly liquid water. But in order to have liquid water, or any kind of habitability, you obviously have to have proper atmosphere. And so pretty much all of the first studies are going to be focusing on figuring out what kind of atmosphere these planets have by looking at the types of emissions they currently produce. And the way that it's done right now is by actually doing this. The scientists look at the planet orbiting the star in order to find minute differences in the reflections coming from the surface of the planet, and by looking at what's known as the secondary eclipse, when the planet moves behind the star. And what this allows us to do is calculate the amount of mid-infrared light with a very specific wavelengths that seems to be coming from the day side of the planet. To be more exact, it's actually measured in microns, and James Webb is perfect for measuring 15 micron wavelengths of light. And the amount of mid-infrared light is directly related to the temperature on the surface, which is generally influenced by the atmosphere of the planet. To be more specific, carbon dioxide usually absorbs 15 micron light. And so, for example, if there was a very thin carbon dioxide atmosphere with no clouds, you would see a dramatic dip that you see right there in blue. If there was a very thick carbon dioxide atmosphere, you would see something similar to the yellow line. Here it actually is a Venus-like atmosphere with sulfuric clouds. Green suggests something that has no atmosphere, or basically barren rock, with the actual detection being the red dot. Here's a slightly more detailed version from the paper itself. And so what this kind of implies right now, based on the observations and the very thorough analysis from the paper, is that there doesn't seem to be anything. Or in essence, because carbon dioxide usually absorbs these specific frequencies, and nothing like that was observed in this case, the planet appears to be either barren or potentially contains very different atmosphere. Okay, so it doesn't actually mean that it's barren, it just means that it's very likely not Venus-like and not carbon dioxide based. But there could still be some other options, including atmospheres that are just exotic. So for example, this could be a planet with an oxygen-dominated atmosphere that would not be detected with this technique. But explaining the origin of this oxygen would be difficult. On Earth it's usually produced by life, but generally we believe it's also produced by dissociation of water into hydrogen and oxygen. So that means that this planet would have to have water. But because of the proximity to the star, it's quite likely that this is actually a really hot planet. So the presence of water here would be very difficult to justify. On the other hand, it could also be ammonia or methane, similar to Titan. But once again, because it's so close to the star, these types of atmospheres would very likely be destroyed extremely quickly. So the methane and ammonia would have to be replenished by something like, for example, life. No evidence for any of this exists just yet. We could obviously have water-based atmosphere as well, but it's the same problem as before. Where is the water coming from, and how is it actually surviving here? So here you would actually have to have a really huge ocean on the surface for any of this to make sense. Because the star in this case is 7.6 billion years old, it's quite likely that these oceans would have to survive for a very long time, and based on the density calculations, at the moment this is not a very likely explanation. These are most likely rocky planets and potentially do not have any oceans. The other option is hydrogen and helium, similar to Saturn and Jupiter, but these types of volatiles do not really exist for a very long time unless the planet is really massive. So once again, quite unlikely. And the last but not least, or technically the most important atmosphere, would be nitrogen-based. That's basically the atmosphere of planet Earth. Most of the atmosphere here is nitrogen. Now that would be kind of difficult to detect right now, and also we don't even know where nitrogen on Earth came from. Mostly because nitrogen is also not particularly stable and does escape pretty quickly. And so because of the proximity to the star, it's also unlikely to be nitrogen. It's not going to survive for so long unless there is a source somewhere replenishing nitrogen all the time. And so unless they contain nitrogen from the beginning, it's extremely unlikely to have that either. And so the most likely candidate here was always carbon dioxide. Very recently, NASA released this beautiful visualization of carbon dioxide cycle right here on planet Earth. And so if we could see how this gas propagates, this is sort of what it would look like. And in this case, CO2 usually radiates energy away pretty well and doesn't actually escape the planet very easily. And so even though on a cold planet it can sometimes freeze turning into ice, it's still a lot more likely to exist, just like it exists on Mars, Venus, and planet Earth. And it's also relatively easy to see it on the planet with telescopes like the James Webb. And through dissociation from the solar radiation, it can also turn into carbon monoxide and even ozone, basically providing a lot of necessary conditions for potential life. And so the initial hope here was to discover some kind of a sign of CO2 somewhere on the surface. But just like with TRAPPIST-1b, the extremely detailed observations revealed either no atmosphere or extremely thin atmosphere that's not going to be having any major effects on the surface. With the surface temperature measured to be approximately 107 degrees Celsius or 220 Fahrenheit, and the reflectivity showing us that it's most likely just barren rock and nothing else. Okay, it could be some kind of an interesting rock, but based on the reflection right now, it looks to be a little bit more similar to, for example, Mars than something similar to planet Earth. Although the actual observations do seem to be very different from what the scientists initially proposed and from what they initially simulated. It doesn't seem to resemble any planet the scientists imagined initially. And so with a relatively high surface temperature, and also being a third as massive as planet Earth and about 10% larger, it basically presents us with a very different world from anything we thought it would be. Potentially a large, massive barren rock, pretty hot on one side and possibly very cold on the other side. And so if there was any atmosphere, it would most likely redistribute some of this heat. In this case though, there doesn't seem to be any redistribution whatsoever. The temperature just doesn't change much at all, basically making this planet a kind of a supersized Mercury. So 2 planets down, 5 to go. Now the first 2 were not particularly exciting to begin with, simply because they were just too close to the star. The next 4 though are very exciting. D, E, F and G are actually the planets that a lot of us are super curious about, and the planets we're most likely going to be hearing about before the end of 2023. Well, it's time for a new James Webb Space Telescope update, and in this case I actually wanted to focus on some of the major discoveries coming from the Milky Way galaxy, but specifically in regards to various nebula and the idea of star evolution, from the birth of stars all the way to their end. And that's because in the last few months, James Webb Space Telescope was able to capture some absolutely breathtaking images of quite a lot of well-known, gorgeous nebula. And though obviously we've discussed quite a lot of previous discoveries and talked about some of these images before, in this video I wanted to focus on some of the major discoveries in regards to the science behind these images and what exactly these images have taught us so far on how stars evolve in the Milky Way galaxy. So, hello wonderful person, this is Anton, and let's discuss various JWST nebula captured in the last few months. And let's start with one of the closest images to us, but also maybe one of the most breathtaking when it comes to the actual scale. This was released very recently, and it's essentially a close-up of a very well-known molecular cloud, Rho Ophiuchi, a gorgeous molecular complex containing approximately 50 young stars, with all of them surprisingly very similar in mass to the Sun, which in some sense basically shows us what probably happened approximately 4.6 billion years ago when the Sun was formed as well. It very likely started with a very similar molecular cloud. And at 390 light years away from us, this is the closest such object. But what exactly are we looking at? Well, I think the biggest structure here are these bipolar jets of molecular hydrogen, visible in red, that in essence are being expelled by various young stars in the middle. Now we'll actually discuss this in a few seconds, but in essence, once stars start forming in a lot of these complexes, they will often produce these very unusual, long tendril-like formations because of what happens right around the center of the star. We obviously think our Sun must have gone through this as well. Although some of these stars that you can kind of see in front have already sort of developed themselves, with many of them expelling most of the dust and very likely already developed into fully functional planetary systems. And so to some extent this image shows us the beginning of everything for most stars. So pretty much every star around us began in one of these clouds. But if you were to zoom in on one of these stars, or essentially try to zoom in on one of these very long tendrils, you would most likely be looking at something like this. Now this is the second image I wanted to show you of an object known as HH211. HH stands for Herbig Haro, and in essence all Herbig Haro objects have a very similar structure. This is probably the most famous one, the one we've discussed in one of the videos in the description. All of them are very young stars, possibly only a few thousand years old and still growing and developing. But just like your typical black hole or neutron star, because these are fast-spinning magnetic objects, that also possess an accretion disk, they eventually develop these polar jets that travel through interstellar space at very high velocities. Now, if this was a black hole, the velocities would be very close to the speed of light. But because this is a baby star, here the velocities are much more modest. In this case, it's maybe about 80 to 100 kilometers per second. And based on the observations from similar Herbig Haro objects, it became possible to analyze exactly what happens much closer to the center where this huge outflow occurs. And that's despite the distances. In this case, it's about 1000 light years away from us. And so here we seem to have an object that's about 8% the mass of the Sun, but it seems to be growing very rapidly. And that's actually because the accretion disk and the polar jets form a sort of a fountain around the star where quite a lot of material gets deposited into the star, but also quite a lot of it gets expelled in these jets. In some way, you could maybe imagine it like this: a huge funnel powered by the magnetic field and the gravity from the star. But for this object, the outflow very close to the star is a little bit slower, which suggests that the materials coming out of there seem to be a little bit heavier. In this case, it's probably molecules and not just atoms. And so here, it's not just hydrogen, which probably moves much faster, but also much smaller, potentially organic molecules, including things like carbon monoxide. So in essence, there's a kind of a multi-level flow coming from the center of the star. There's obviously a flow of hydrogen, but there's also a flow that moves slower that seems to include much heavier molecules, which by itself shows us the next step in star evolution. Following the formation inside the molecular cloud, a lot of stars experience this for thousands and thousands of years, eventually evolving and developing into final objects, main sequence stars. Although in this particular case, scientists have also detected some kind of a wiggle, which implies that this is probably a binary system. Another object seems to be pulling on something in the center, creating an outflow that's not entirely straight. So we're basically observing a formation of a binary system. Although intriguingly, when it comes to star formation, a lot of these observations from various nearby molecular clouds show us something a little bit different from what happens closer to the center of the galaxy. And in the center of the Milky Way, there is a region known as CMZ, Central Molecular Zone, a region containing giant molecular clouds that seems to be 2000 light years across and contains 60 million solar masses of material. And right there in the middle, there's an unusual region known as the brick, something that looks like this if zoomed in. And so the recent observations by the James Webb were able to analyze this massive cloud gas that's sometimes referred to as the infrared dark cloud, showing us what's happening here as well. And generally speaking, these types of molecular clouds or these types of regions are extremely different from what we have much closer to the solar system. They're way more denser, containing a lot more stars, and potentially also a lot more star formation. Although the brick seems to be a little bit different. It shows less star formation compared to regions nearby, but seems to be just as dense and seems to contain just as much turbulence. But because this is such a dark region and because a lot of dust blocks a lot of light, it's always been a very difficult region to study. Nevertheless, despite being somewhat dark and appearing somewhat inactive, it seems to contain at least 56,000 stars that are being formed there right now. And surprisingly, this is actually on the lower end for this unusual central region. Many other locations here have way more stars being formed much faster. But previously all of this was kind of invisible. Now it is visible because of carbon monoxide, the gas that's very bright in certain infrared frequencies. And turns out that this brick region contains huge amounts of carbon monoxide that seems to act as a kind of a coolant. And since star formation usually happens in much cooler regions, especially in dense regions of similar gases, technically we expect a lot of stars to form here, because finding so much carbon monoxide generally indicates higher rate of star formation. But that's not what's observed here, because for some reason the gas here is a little bit warmer. And at the moment that's a mystery nobody can explain. So basically all of the gas present here should be forming stars, but it's not doing that, because something in the central region is warming everything up. Nevertheless, the discovery of so much carbon monoxide is definitely kind of exciting. The ratio of carbon monoxide to hydrogen is much higher than anywhere else in the galaxy. And so trying to understand exactly what happens in these regions and how the star formation here might be a little bit different is going to be one of the future goals for the James Webb staring at the center of the galaxy. Right now this is really more of a mystery that nobody still understands. And then we of course had some really exciting observations from the famous Orion Nebula. Specifically the Orion molecular cloud, where even more stars are forming, with many once again very similar to our Sun. And here the scientists discovered something that was really surprising. It's known as methanium, sometimes referred to as methyl cation. Basically a carbon compound that seems to be extremely important for organic chemistry happening in the interstellar space. And though it's not something that naturally exists on planet Earth, it seems to be absolutely crucial for a theoretical explanation involving various complex organic molecules detected in outer space, including various amino acids, or building blocks of life, that were discovered by various telescopes in the last few years. The only way to explain their existence or how they could form is through various complex processes that must happen in outer space in various molecular clouds, which by the way is directly connected to the potential existence of life on other planets, or even to evolution of life on planet Earth. Huge amounts of these compounds most likely came from outer space. And so by conducting observations in the Orion Nebula, a team of scientists discovered methanium hiding in plain sight, located in quite a lot of regions of the Orion Nebula, suggesting that it's basically performing a lot of chemical reactions right now, with the main focus being this unusual star named D203-506, some sort of a small red dwarf that's obviously still growing, and that's also receiving a huge amount of UV radiation from many nearby stars. These types of environments are very common in many molecular clouds, but these very massive stars producing UV light only exist for a few million years. They go supernova afterwards. And though these very powerful types of radiation are supposed to destroy a lot of different complex molecules, it does not seem to be the case here. Because it turns out UV radiation promotes the formation of methanium. And so once those stars disappear, in theory there's a huge amount of methanium floating around various stars and in the interstellar space, which is precisely what's been detected here as well. And what's really strange about this unusual molecule is that it doesn't react with hydrogen, but it loves reacting with a lot of organic compounds. And so it acts as a kind of a stepping stone for the formation of more complex molecules that then produce things like amino acids. Although in this case also showing us that UV radiation in general seems to be critical for the formation of complex chemistry in various molecular clouds. In essence, explaining how a lot of complex stuff must have formed in the solar system as well. So yeah, some really cool discoveries. But so far we've just talked about formation of stars. Now obviously James Webb has looked at various developing stars, but it also looked at stars very close to the end of their life, or even stars that have already transitioned into something else. And so here let's take a look at some of them. For example, there was the image of what's known as a Wolf-Rayet star, in this case WR124, that represents a massive star that's most likely going to go supernova in the near future. And here, as these stars evolve, they form these huge shells around themselves, even visible from a distance of 15,000 light years. Now this particular star is about 30 times the mass of the Sun, but it already released approximately 10 solar masses into outer space. That's what you actually see around it. And here the main point is trying to figure out how these various stars contribute to overall dust in the entire galaxy. All of this dust will eventually get recycled, forming new stars, and so trying to see what kind of a dust is being released is obviously kind of intriguing. Although in this case, one of the main discoveries is just the observation of various very clumpy regions that seem to form as they're expelled from the star. It's not entirely clear where all of this goes just yet. But eventually the star is going to go supernova, and is going to produce something similar to this. This is the other observation from the youngest supernova in the Milky Way. It's known as Cassiopeia A. This most likely happened about 340 years ago, but it looks like nobody on Earth might have actually seen it. We've talked about this a little bit more in one of the videos in the description, but one of the reasons is probably because it's kind of far away. 11,000 light years away from planet Earth. And so once these massive stars explode, they once again produce another beautiful dust cloud, obviously different from the ones we saw previously. And here it seems to once again produce these various clusters or various mini bubbles with a lot of really complex shapes, and more importantly, unlike previous clouds that usually contain light elements, here we have a lot of heavy elements: oxygen, argon, neon, and of course a lot of metals like calcium and iron. But here there are also unusual structures that are still kind of mysterious. For example, these unusual green protrusions that scientists are referring to as the green monster. It's not clear what exactly produced this, but these seem to be all over the place. And so in essence, by observing these supernova remnants, we're looking at the end of star formation as the stars evolve and as they finally release all of the heavier elements that they managed to create over millions of years. But in this case, this was very likely a much more massive star. What about stars like our Sun? Most stars out there are much less massive, and so they actually produce something a little bit different. And here we're talking about what's known as Planetary Nebula. This is the famous Ring Nebula recently observed by the James Webb. Here this is an expanding shell of gas coming from the star in the middle that occurs when the main sequence star, like our Sun, first becomes a red giant, then becomes a white dwarf. Now this object is about 2600 light years away from us, but it's one of the most well-known planetary nebula and one of the most studied objects. Here the star in the middle is a white dwarf, approximately 0.58 solar masses in mass. It's also surprisingly really bright and very hot, 135,000 Kelvin, 310 solar luminosities. But this is something we've known before. But the James Webb was able to discover something else. For example, approximately 20,000 unusual dense clumps that you see right there that actually seem to contain almost half of the total mass released from the star. And quite a lot of the material here represents very complex organic molecules, such as for example the very important polycyclic aromatic hydrocarbons, a very important precursor that's responsible for forming everything inside our bodies. But the more detailed examination discovered at least 10 different arcs, suggesting 10 powerful emissions when the star was in its red giant stage. There are also approximately 400 different spikes that seem to have formed as a result of some kind of a turbulence. And surprisingly, there are also quite a lot of carbon-based molecules whose origin is currently unknown. Although some of these formations and some of this turbulence is most likely because this is technically a triple system. The central star has at least 2 companions, and the farthest one seems to be a red dwarf as well. But in this case, we basically get to see the other side of star evolution. The end of life for most stars out there, the ones that cannot go supernova. And in this case, they also recycle their gas, but different gas in somewhat different ways. Unlike a supernova that produces a lot of heavy elements, here we get a lot of organic molecules and a lot of lighter elements that then become interstellar gas. So super exciting stuff, and just like after 1 year of operations. So you can only imagine what we're going to find out in the next 10 years or so. I'm super excited about these future results, and I'm sure we're going to learn so much more about star evolution in the next few years. But there were of course so many other images captured by this iconic telescope. We've discussed many in some of the previous videos, and we'll definitely talk about other ones in some of the future videos as well. But before we finish this video, I wanted to mention a couple that were not in the Milky Way, but also showed us something really important. One of the most important observations was actually a combination of James Webb and the Sophia telescope that's now officially retired. This was the observation from the iconic Tarantula Nebula, and specifically the cloud known as R136. This is where we find huge amounts of massive stars, and basically the most massive stars discovered in the entire universe. Now here, this is what the new image looks like. It shows us the magnetic fields and the interplay between magnetism and the gravity. And because these are very complex magnetic fields, they seem to produce very surprising results. They basically seem to prevent certain gases from forming stars in certain regions. Now first of all, this nebula is forming stars ridiculously fast. It actually kind of mimics what happened in the universe approximately 11 billion years ago. But if you look at this image, you'll see that in some regions there are no stars, which was a bit of a mystery at first. Turns out that a lot of these regions seem to also have powerful magnetic fields. These regions resist turbulence and prevent gravitational collapse. And so only in the regions where the field is much weaker, the gas is able to escape and eventually form stars. But here, the power of the magnetic fields definitely acts as a kind of a switch for star formation in the entire cloud, while also potentially holding everything together. Technically, the cloud should have fallen apart a long time ago. And intriguingly enough, most of these fields are produced by the stars themselves, or specifically by various activity very close to them, so in some sense it's a kind of a feedback mechanism. More star formation leads to more stars, leads to more magnetic fields, which then can actually shut down star formation in certain locations. So definitely some intriguing results, but still not super clear on how all of this works. And since we've talked about the Large Magellanic Cloud, here's also a picture from the Small Magellanic Cloud, another beautiful star-forming region containing thousands of stars. In this case, one of the most exciting discoveries here is the presence of thousands of different filaments in this region known as NGC 346. And as I mentioned in the beginning of the video, all of these filaments are very likely baby stars with very powerful jets. Basically gas that's being blown away from young stars, as many of them seem to form around the cloud. Although in this case, what's exciting about this cloud is that it seems to have a lot of material that's somewhat primitive, very similar to how it was billions of years ago, making this one of the most interesting star-forming regions visible from planet Earth. Something we'll probably come back to and talk more about once there are more discoveries. At this point, I should probably start a series called Crazy Stuff Nobody Expected That James Webb Discovered, and we still have no idea what it is. Because once again, that's exactly what we're talking about today. Hello wonderful person, this is Anton, and today we're discussing something from the famous Orion Nebula. Something that the scientists discovered very recently when new detailed analysis of the Orion Nebula, and specifically a location known as the trapezium, revealed objects nobody has ever seen before, and nobody understands how they formed. The objects scientists are currently calling jumbos, Jupiter mass binary objects. And I guess as the name implies, they seem to be binary objects very similar to planet Jupiter in mass, but exactly what and how they formed makes no sense. But I guess more intriguingly, at least 42 have already been discovered in just the last few days. More are probably hiding inside. And so in this video, let's discuss this unusual discovery, but also discuss the incredible images released by the James Webb that you can actually explore yourself by using an amazing tool from ESA, a browser-based application known as ESA Sky. Basically a visualization of everything we know and have so far from most of the modern telescopes. And yeah, that's literally astronomy at your fingertips. If you ever want to study astronomy by yourself, this is precisely where you start. Here you can technically fetch almost any data from any telescope and then use it for your own analysis or your own studies. Obviously you have to know what to do with those images, but they're right here. Which is why there are two modes. Science mode, this is more for scientists, or for anyone wanting to do science, or Explore mode, for people that just want to look around. And though quite a lot of older images will usually look somewhat outdated and somewhat blurry, once you switch into the James Webb mode, things become way more clear and you actually get to see a lot of detail you've never seen before. And so for the Orion Nebula, and specifically for the trapezium, we get two different channels. We get the short wavelength versus the long wavelength. They do show us slightly different detail, and obviously reveal slightly different objects, but in order to try to discover some of the objects we're going to be discussing, we have to look at things in short wavelengths. There's actually a lot of stuff going on here. This image is absolutely mind-blowing. Even trying to zoom in right here, where you suddenly discover this enormous explosion covering a very large area with a lot of finger-like protrusions going in every direction, already raises a lot of questions. What exactly caused all of this? As a matter of fact, the center of all of this seems to be somewhere right here, maybe. And while a lot of these fingers, these unusual red features, these are known as the Orion Molecular Cloud 1. This is essentially an outflow, and specifically an outflow of hydrogen gas, which most likely resulted from a collision between two giant stars. And because this is so fast, moving at approximately 100 km per second from this direction, scientists believe that it happened somewhere right here a few hundred years ago. And it's almost certainly a collision between two stars because of these unusual green patches you see right here. Now this is not really green in real life, these are just frequencies of infrared light converted to visual spectrum, but this green stuff is iron. And this iron was produced as a result of a massive star collision. It would be very difficult to explain the formation of these fingers with these red fingertips through any other means. Anyway, definitely super beautiful and an extremely gorgeous event that you can actually see for yourself by using your browser. Now if you look around, you'll find a lot of other really intriguing stuff, and specifically objects that maybe look something like this. And it becomes pretty obvious what this is once you start zooming in. And just the fact that we can see this from approximately 1400 light years away is of course mind-blowing. Here's another one that's maybe a little bit smaller. And as you might have guessed already, these are basically protoplanetary disks. Let's put one right here as my little hat. So essentially, baby stars turning into baby planetary systems. And if you look around, you'll find quite a few of these, although most of them are a little bit difficult to spot, with a lot of them containing their own secrets as well. It's uncertain, for example, what exactly is around this one. Or this one that seems to contain some kind of a cometary tail. But because the Orion Nebula contains thousands of young stars, it's obviously not surprising we can see these objects. We just couldn't see them before because they were hidden by gas, but the James Webb can see through the gas, revealing their presence. And here you can actually even guess the mass of the star by seeing how large the object appears. Some of the larger ones go up to 40 solar masses, with some of the smaller ones only being about 10% of the solar mass. But what's intriguing is if you look around these objects and if you actually spot any large and really bright stars, it even becomes possible to observe the effects that the solar system, or specifically the sun, received in its childhood as well. In the first million years, the intense ultraviolet radiation from some of these really massive stars quite dramatically affected the disk of the solar system in the first million years. And this is actually what's happening to many of these stars as well. And the more neighbors they have with powerful UV radiation, the more of the disk gets destroyed, eventually producing very different planets. For example, the effects on this particular star seem to be quite dramatic, to the point where even the shape of the disk seems to be changed a little bit. So the neighborhood of the star system also affects the types of planets the star will produce. I guess you could almost say it takes a village to raise a child. Okay, maybe not the best comparison here, but you get the point. But one of the reasons this whole region is called trapezium is actually because of these 4 stars you see right here. They essentially form a trapezium, a geometric shape. These stars are only about 1.5 light years away from one another, but are directly responsible for most of the illumination of everything around them. These are really powerful, really massive, and very bright stars. And so they're actually the ones changing most of the things in the neighborhood. Although in total, if you were to zoom out, there are thousands of different stars here, which are going to be producing several thousand different planets eventually. But while investigating this image, the more experienced eagle-eye astronomers started to discover these unusual binary objects. Essentially objects that appear to be possibly very small, maybe Jupiter-like, simply based on the heat they were producing, suggesting that they were not really stars, but strangely enough, almost always appearing in pairs. And there's actually quite a lot of them in this image if you look around. In total, they discovered at least 42 so far, and you can find information about most of them in the study in the description. All of these seem to be a little bit more massive than Jupiter, but not brown dwarfs, so they're definitely planets. But like binary planets. And it's not entirely clear what they're actually doing there or how exactly they were created. Now today, when it comes to planets, and specifically planets without stars, or the so-called rogue planets, we understand they can be generally created by either being kicked out of the star system, possibly through some kind of a gravitational interaction with something else, or by maybe being formed entirely by themselves from just a much smaller amount of material, although that process is not entirely well understood. But binary planets, that's definitely unheard of, because essentially it suggests either 2 planets were created very close to one another and then somehow got kicked out of the star system, or these 2 planets were somehow created without a star, but instead of one object, they formed 2. But not 2 objects close to one another, 2 objects orbiting relatively far away. Here the distance seems to be approximately 100 astronomical units. And at the moment it has absolutely no explanation. Nobody knows what these jumbos are. They seem to be a new mystery of the Orion Nebula. At the moment the best explanation is the ejection hypothesis, suggesting that 2 planets were basically thrown out of the star system and then somehow joined together and started orbiting around one another. But because this happened at least 42 times, it just means it's some kind of a mechanism that we just maybe don't understand or have never imagined happening anywhere. But according to modern star formation theories, just by itself, a typical Jupiter-sized planet should not actually have enough mass to form into a single solid object inside a nebula. A brown dwarf can form, but maybe not a Jupiter-like object. And so whatever these things are, I guess maybe time will tell, but we're not going to know for quite a while. Although this raises an obvious question: if these double Jupiters exist, what about other types of planets? Could there be maybe similar double Earths orbiting somewhere else as well? Especially if this is an ejection hypothesis idea, nothing is stopping stars from throwing away planets like planet Earth and then turning them into rogue planets, but instead of one Earth, you have two. Not something we're going to be able to answer anytime soon, but it's definitely an intriguing question. But in terms of what we know about them so far, well, they all seem to be relatively young, possibly around 1 million years old maximum. And the ones detected so far are also very hot, around 1000 degrees Celsius or around 1800 Fahrenheit. Because these are new observations, not much else is known about these strange jumbos. But there is, however, another intriguing explanation related to previous assumptions and previous explanations in regards to this sector of Orion. Some of the former studies, specifically back from 2012, made suggestions that maybe somewhere inside of here there is some kind of an intermediate mass black hole, at least several hundred solar masses, which could be responsible for dispersing things in this cluster, providing them with so much velocity in the process. A lot of stars and a lot of material here is actually moving really fast. And if there is some kind of an intermediate mass black hole, in some sense it might be the culprit behind these unusual planets. A compact massive object can occasionally strip planets away from the stars if they pass relatively close to it. But because these planets would not be falling into the black hole and would be just passing by, if enough of them was stolen, some of them maybe could somehow combine into binary systems. And so there's at least one more potentially unconventional explanation to what's really happening inside this unusual nebula. Today I wanted to take a look at some more discoveries from the James Webb, once again focusing on the edge of the observable universe, or essentially the so-called cosmic dawn. The first 1 or 2 billion years after the universe was created, that the scientists today are trying to understand a little bit better in order to understand how the universe evolved over time. And as you already know from some of the previous videos, in the last year and a half, James Webb Space Telescope made quite a few somewhat unusual and potentially very unexpected discoveries. But I really wanted to start with this. This is actually a recently released website that you can find in a link in the description that has now been released by the James Webb team for everyone to peruse and for everyone to enjoy. And this shows us a tiny piece of night skies that's essentially been observed by the James Webb for a long time during the so-called JWST Advanced Deep Extragalactic Survey, also known as JADES, with the light from some of the more distant galaxies traveling for essentially 13 billion years. And so basically this is one of the first deep field images released by the James Webb team that now anyone can look at. And you might even discover something nobody has ever seen before, or something that's surprising or unusual. And there is quite a lot of stuff to explore here. Approximately 100,000 different galaxies. And if you extrapolate this to the entire night skies, it means that there is at least nearly 1 trillion galaxies in the entire observable universe. But even going through these 100,000 is obviously going to take a while. And so if you're going to be taking a look at this, well, just to give you some hints, first of all, if you see something bright that has a lot of spikes, that's most likely a star, as in a star in our own galaxy. But if you see something like this that has possibly a star and a galactic shape, it could be either a star in front of a galaxy, or it could be a very powerful quasar, or basically an active galactic nucleus, a big black hole. And if you're not sure what exactly this is, right here in the top right corner, you can actually change some of the frequencies of light to maybe see this in a different light, which can actually then maybe help you figure out exactly what this is. And so yeah, it looks like this is a star in front of a galaxy, not a quasar. And of course there are quite a lot of other galaxies that just look like galaxies, with many extremely far away. And I think here's one that possibly is a quasar, because it does appear more like a hotspot in the middle of the galaxy, not really as an individual star. And so lots of different objects to explore here, if you want to try something different. And hello wonderful person, this is Anton. Let's talk about some of the major discoveries from the last few months coming out of the James Webb, specifically focusing on things nobody expected. And let's actually start with one in regards to quasars and black holes. Because one of the main goals for the JADES program is to essentially try to figure out the mystery of ancient black holes. How exactly did they form? How did some of them get so massive, so extremely fast, and how did they influence the evolution of galaxies, and of course, the formation of stars. And relatively recently, the scientists did discover a somewhat unusual black hole extremely early on. We've actually discussed this in more detail in one of the videos in the description, but it's essentially a black hole that's now been confirmed to be a black hole, referred to as UHZ-1. It existed approximately 470 million years after the Big Bang, and it seems to be about 40 million solar masses, 10 times as big as the one in the Milky Way. But what makes this black hole unusual is of course its mass compared to the stars in the galaxy. It seems to be at least 10%, possibly more than that, of the entire mass of the galaxy. And that's very unusual. In pretty much most galaxies known to us, usually the mass ratio is much lower. Only some very unique galaxies, like the ones we've discussed in the video in the description, the super compact galaxies, have a similar ratio of star mass to the black hole mass. So by itself this is kind of strange. Nevertheless, it's clearly there, it's also very active, and it was detected by both Chandra and James Webb Space Telescope. But despite this detection of a massive black hole, there is actually something else very unusual that was discovered recently. Previously, a lot of scientists had an assumption that we're going to find a lot of black holes in the early universe, and they should be all over the place, helping various galaxies evolve, producing tons and tons of light, possibly even serving as the main mechanism that essentially caused reionization of the universe. And specifically, they expected to find a lot more black holes compared to the previous survey conducted by Spitzer telescope, but they didn't, suggesting that they seem to be growing much slower and that they're also in much smaller numbers, basically implying that, for some reason, a lot of these early black holes are definitely not growing as fast as a lot of studies anticipated, and more importantly, do not seem to have as much an effect on these early galaxies as we always thought. It was actually believed that maybe supermassive black holes were one of the main forces behind the early galactic evolution, but this study suggests otherwise. It really suggests that ancient galaxies and ancient black holes behave differently from today and very differently from what we expected. But then if it's not black holes, then what? How did the galaxies evolve and became the way they are? Well, some of these answers can actually come from this image I previously showed you, because once again a lot of these new discoveries suggest that the galaxies themselves were actually much brighter and were glowing much more than we ever thought possible. Here, a lot of these galaxies during the cosmic dawn, and here we're talking about 90% of all of them, had a huge amount of glowing gas on the inside, producing very extreme emission lines not seen in any modern galaxies. Which of course suggests that not only were these galaxies different in terms of the way they looked, they were also very different in their fundamental properties. For example, a lot of these teenage galaxies that existed for maybe a billion years or so turn out to be extremely hot as well, with temperatures of about 13,000 Celsius or 24,000 Fahrenheit, or at least in some of the hottest areas in the galaxy. And that's much hotter than anything in the Milky Way. And so overall, all of this kind of suggests that many of these early galaxies potentially resembled a typical nebula. They were basically super bright, glowing with a lot of light, producing a lot of heat, with all of this being the excitation of all of this gas by very powerful stars in the middle. And so they basically resemble these huge glowing clouds. Maybe not as bright as some nebula, but definitely much brighter than any modern galaxy. Which would explain why many of these galaxies appear much brighter than the scientists anticipated when they started looking at them. And a lot of this brightness is really the result of extremely fast bursty star formation that essentially produces a lot of ultraviolet light, a lot of brightness and a lot of heat that then illuminates the rest of the galaxy, overall making this early universe a much brighter place. But still a somewhat surprising place, because when the researchers were looking at some of these galaxies, they were also able to analyze their spectra, discovering what elements they have on the inside. That's the beauty of using the James Webb, it's able to do that. And here they started finding a lot of materials that were not just hydrogen and helium, which though made sense for some of the more advanced galaxies, did not make a lot of sense for some of the younger ones. And at least one galaxy located at a redshift of 12, or basically when the universe was only 350 million years old, turned out to contain stuff nobody expected. It was enriched in metals. Okay, side note. In astronomy, metallicity just refers to anything that's not hydrogen and helium. So this galaxy was enriched in other stuff. Specifically, there was carbon, there seemed to be nitrogen, there seemed to be oxygen, and even neon. Even though technically we only expect hydrogen, helium, maybe a little bit of lithium, and potentially just tiny bits of beryllium. All of that was there too, but with extras, making this the first confirmation ever of a galaxy at a redshift of 12, that seems to suggest a lot of complex elements already existed back then as well. And normally metallicity is super important for example, planetary formation, because obviously most planets today contain non-hydrogen and non-helium elements. But even for the evolution of galaxies and stars, it's kind of important to understand how everything started. And while the original explanation always involved the idea of so-called population 3 stars, massive stars containing just hydrogen and just helium going supernova, creating more complex elements. One of the goals of James Webb is to try to find these stars. But because the scientists discovered carbon, neon, nitrogen, and so on, it potentially implies that a lot of these early stars, population 3 stars, were not actually just made of hydrogen and helium. Or maybe even that population 3 stars are a somewhat incorrect hypothesis. Although obviously here we don't really know where this carbon came from and what created a lot of these other elements. For example, one suggestion is that there were population 3 stars that exploded, but all this happened very quickly, and so now we're just seeing the evolution of the second stage. The other suggestion is black holes, or specifically the central black hole. Maybe it was powerful enough to somehow influence everything, and was able to enrich the chemical abundance inside the galaxy. And so yeah, just for now it's going to be a mystery, without an actual answer. But despite all of these mysteries, there were also some discoveries that provided a few answers. For example, one of the observations revealed 20 galaxies relatively close to each other that seem to be forming a new megastructure. It's actually now known as the cosmic vine. It seems to be 13 million light-years across, 650,000 light-years wide, and existed about 12 billion years ago. And it essentially represents what's known as a protocluster. We're seeing a formation of huge galactic clusters that now exist everywhere around us. If you want to learn more about these, check out one of the recent videos about Laniakea, the supercluster where we live. And on top of this cluster is still growing, and seems to actually be one of the biggest clusters discovered so early in the universe. But intriguingly, around this time, another team of scientists discovered another protocluster even earlier. This one, 13.1 billion years old, basically the oldest discovered so far. Although here we only see 4 galaxies, but definitely also combining, coming closer together. If simulated, it would look something like this. And so because this earlier cluster has only 4 galaxies, the slightly older cluster has 20, and much older clusters have a lot more, we basically get to see the progression of how superclusters formed over time by basically seeing these tiny slides of the past. And that by itself matches with all the predictions scientists have right now about how clusters form, and of course about how universe evolved as well. And so at least in terms of the bigger structure formation, most things here seem to kind of make sense. Even though when it comes to individual galaxies, things are just a little bit more surprising. But at least one more discovery, a somewhat interesting discovery, came from a different telescope from the James Webb. It actually came from ALMA. And here this was the image of a galaxy known as 9IO9 that's actually kind of difficult to see. It's that red arc around the brighter galaxy that you see in the middle. And so basically this is a result of a gravitational lens. And so that lens galaxy that existed when the universe was about 2.5 billion years old revealed something we always wanted to see but could not see because most of these galaxies are practically invisible. The scientists confirmed the existence of magnetic fields. And here we see emissions approximately 16,000 light-years across, but approximately 1,000 times weaker than what we have on planet Earth. And all of this is seen because this is essentially various polarized emissions from the dust inside this galaxy that just seems to be very active, forming stars about 1,000 times faster than the Milky Way, and as a result seems to produce very powerful magnetic fields. And because of this vigorous star formation, and because in this case the fields are actually oriented parallel to the molecular disk, it essentially confirms that many of these structures inside of these galaxies can form very rapidly and produce a lot of radiation and a lot of light, which is precisely what I mentioned previously and what was actually detected by the James Webb. So in that sense, these two stories kind of relate, with one just showing things in a slightly different frequency. Here we basically get to see polarized light produced by powerful magnetic fields. And all of this to some extent hidden somewhere in one of these images. Hello wonderful person, this is Anton, and today we're going to be discussing one of the more intriguing discoveries coming from the James Webb Space Telescope that was officially made a few months ago and has now ended up in this particular paper that hasn't really been peer-reviewed yet, that suggests we might have discovered signs of some of the first stars in the universe. The mysterious and never before seen population 3 stars. The stars that might have been created in the first few hundreds of millions of years from the primordial gas that existed in the universe, and the stars whose properties or even whose appearance we still cannot really describe. But the stars that the scientists have been trying to discover for the past few decades. And this is actually a really intriguing potential discovery, assuming that it's correct, even though, as the scientists behind the study imply, it would be extremely difficult to definitively say what exactly this is. But let's actually discuss what this is all about, and why, if this is correct, it's actually a pretty exciting discovery. And here, as always, we have to start with a bit of a history, with this person right here, Walter Baade, a German astronomer who used to work in the United States, who back in 1944 proposed that most of the stars should actually be just classified as two major types, independent of what they contain on the inside. Either population 1 stars or population 2 stars. In this case, population 1 stars would be stars like our Sun, the majority of the stars we observe in the entire galaxy. And these of course are metal-rich stars, stars containing materials created by at least a dozen, and in most cases up to 100, different supernovae in the past. And as more and more heavier materials accumulated in a lot of these stars, they became more enriched in metallic materials, with younger stars being more metal-rich. And so, for example, based on the metallicity and the age of our Sun, the scientists believe that at least 3 dozen different supernovae were responsible for the creation of this object, possibly even as many as 40 or even 50. But naturally, all of these earlier supernovae were created by older stars, and specifically some of the older stars would be what we refer to as population 2 stars. These would be very poor in metals, or basically mostly containing hydrogen and helium, and in some cases would also be extremely old if they still exist. As a matter of fact, when it comes to the age of the stars, some of the biggest record holders were all population 2 stars. A lot of them are 12 to 13 billion years old. And so I guess in some sense you can see them as parents and grandparents of the Sun. And so that's what he proposed back in 1944. But in 1984, the British Bernard Carr added another population type, population 3. The first ever objects to exist in the universe with star-like properties, or basically with nuclear fusion. And it was the explosion of these stars that then created all of the population 2 stars, which then led to population 1 stars. Confused yet? Well, it's actually just a numbering that's kind of confusing. It really should have been the other way around. But anyway, population 3 stars are the most ancient and are the ones that everybody wants to find. These will be the stars with the lowest metallicity ever, or basically only containing hydrogen and helium and maybe just a little bit of lithium, and would also very likely be extremely different in a lot of other properties. And just a quick clarification, metallicity in this case is also not a very good name. This does not just refer to metals like iron and aluminum. In this case, this term refers to anything that's not hydrogen and not helium. So pretty much everything that's formed during a typical supernova. With a lot of these elements, especially the ones responsible for terrestrial planets, suggesting that high metallicity will very likely result in planets like Earth, whereas low metallicity can only produce gas giants. But that's beside the point. The point here is that population 3 stars are just extremely mysterious. Since these were the first stars, and these were formed from the initial gas, at the moment we have no idea how massive these stars would get, we obviously have no idea if they could have planets, and we don't even know what temperature they had, or what emissions they produced. Moreover, we have no idea what effects they had on the rest of the universe. But it's always been assumed that they were one of possibly 2 types. Either extremely massive and extremely hot, producing very powerful ionizing effects, and actually extremely specific effects such as highly ionized emissions of helium, something we observe from a lot of extremely powerful stars such as the Wolf-Rayet stars, which can generally produce some of the hottest and some of the brightest objects, or maybe being much larger, as big as the entire solar system, thus being less dense and very likely a lot more diffuse, although in this case very likely possessing masses of up to 100,000 solar masses. So in other words, nobody has any idea what these stars might have been like. But they had to have existed because all of this early gas became stars at some point and resulted in a lot of these supernovae and a lot of ionization, which then transformed the universe, making it more transparent. So basically their existence is believed based on a lot of other observations from a lot of other features. But a lot of the initial simulations suggested that in many cases, many of these early stars would very likely collapse into much larger objects almost instantly, and would also very likely exist for just under 3 million years, possibly even less than that. exploding as massive supernova afterwards and creating even more objects. Which basically implies that their actual existence in the universe is an extremely small period of time, something that would be kind of difficult to detect, because it would just represent a tiny slide out of many frames visible as the movie of the entire universe. But nevertheless, in the last few years, some papers proposed a way to potentially discover these objects by looking at very specific emissions. Emissions that will be produced by much denser, much hotter objects, possibly at least 50,000 degrees Celsius in temperature. And so this much older paper from a couple of decades ago made a very specific theoretical proposition that these particular stars would very likely emit a very specific frequency based on the emissions from the helium ionization, something that can only be achieved in some of the most extreme places in the universe, for example around very massive black holes, or, like I mentioned before, around an extremely specific type of Wolf-Rayet stars, which are not generally as common. And a few years ago there was a potential detection of one signature described in a paper that you see right here and can find in the description. But it was quickly established that there were also other emissions, specifically oxygen emissions, that would not be possible if this was coming from population 3 stars. And on top of that, later observations actually failed to find helium observations that were reported in the original paper. And so since that original detection in 2015, the scientists kind of discovered nothing, but a lot of scientists were hoping that James Webb is going to be able to find something because that's actually one of its primary missions. And so pretty much as soon as the images started to come out, the scientists behind this recent paper focused on analyzing approximately 2,000 different targets, looking for these very specific helium emissions. And in December of 2022, they might have found at least one, coming from a galaxy at a redshift of 8.16. Or basically a galaxy that appeared 620 million years after the beginning of the universe. A galaxy that also seems to be split into two different parts, with one half possessing these helium signatures, although also possessing a lot of other elemental signatures as well. Although in this case, it doesn't negate the original proposition, because these could be a mixture of population 3 stars that have already created a lot of younger stars that started to produce a lot of other emissions. And what makes this particular detection interesting is really the brightness of these helium emissions. The strength of the signal implies that this could be some kind of a region rich in population 3 stars, or at least stars possessing extremely similar effects and extremely similar properties. And though in theory it could be just a lot of black holes with a lot of very powerful accretion disks, these types of phenomena also produce very specific oxygen, nitrogen, and carbon signatures. None were discovered in this case, which at least for now implies that this is an extremely intriguing discovery of potentially some of the first stars in the universe, although in this case it's not really the first stars. It would still be population 3 stars that were formed much later, but from some of the primordial gas that existed from the beginning of the universe itself. In other words, if real, these population 3 stars were essentially already coexisting with population 2 stars created from some of the first supernova. But unfortunately, it would still be very difficult to prove exactly what's happening here. This does not provide us with direct evidence or direct observation, just emissions coming from a really distant place in the universe. And so what the scientists are actually hoping to find is maybe something like this: a direct observation of a much larger diffuse population 3 star, possibly as big as the entire solar system, that could then get magnified through the gravitational lensing effects of some kind of a massive galactic cluster, which is actually how a lot of other distant stars have already been discovered, but that would require some extreme luck. And obviously at the moment no such discovery has been made and will probably not be made for a pretty long time. Hello wonderful person, this is Anton, and today we're going to be talking about the phenomenon known as protoplanetary disk. And specifically, we're going to discuss two separate studies that appeared only within a few days of each other, discussing two unusual discoveries from very well-known disks not so far away from planet Earth. In the process confirming that even though we sort of understand how these disks form and how they evolve, in reality there are many things we still don't understand and many things that are still very surprising. And because all of these disks then evolve into various star systems, understanding how they evolve is important in order to understand how various planets form as well. Although generally they've always been seen as this: these pancake-like formations that interact with the star and interact with matter around them in order to at some point start producing planets, which then end up sculpting the rest of the disk and the rest of the star system. Although the actual evolution and the actual sculpting is always different. And so far, no disk has been alike. All of them seem to have something unusual, something unique, and sometimes even something we cannot explain. And one of the main goals of trying to understand their evolution is to basically understand how certain disks evolved terrestrial planets or potentially even Earth-like planets. How exactly did Earth form? But in order to start answering these questions, we first have to start looking around at examples where things are a little bit unexpected. And actually one of the recent discoveries from the James Webb is such example. And it's from a very famous star, Fomalhaut, one of the brightest stars out there and one of the closest such stars to us. A Type A star approximately 25 light years away, that's technically a triple star system containing two smaller, much farther away partners. But we're not particularly interested in these partners just yet. We are interested in the main star, and mostly because it seems to produce an excess of infrared radiation, perfect for James Webb observations. But for a very long time we knew where this is coming from. The excess of infrared radiation is produced by a very large planetary disk. A disk that's actually pretty well known and has been observed many times before because it's also one of the closest to us. In this image, it sort of looks like an eye. But back in the days, it was also one of the first candidates for a potential exoplanet discovered in a nearby star system. A planet that you sort of see simulated right here, known as Fomalhaut b, later on renamed as Dagon, obviously named after the god from H.P. Lovecraft. But even though this planet was optically observed, and was even seen by Hubble telescope as an object you see right here, in the end it turned out to be not a planet. Within just a few years, by 2012, the scientists have actually realized that it seems to be some kind of an expanding dust disk, very likely resulting from an ancient collision. Which is of course ironic because in this case, the name Dagon makes a lot more sense. Ancient catastrophic collision of humongous proportions. But this should not be a surprise coming from this star system here. This is an extremely young star system. It's believed to be anywhere between 100 to maybe 300 million years old, and so the star here is still evolving and still forming planets. The star itself is almost twice as massive as our Sun and has a temperature of over 8,000 degrees Celsius. It's also almost double the size and is about 17 times brighter. And so here the star is way more powerful and way more extreme than our Sun. But the recent observations from the James Webb make it even more extreme. This was reported in the study you can find in the description below. And so here the scientists discovered that it seems to have an extreme debris disk, with the overall protoplanetary disk being absolutely enormous compared to other disks scientists have observed. So here we have an inner disk containing a lot of carbon grains and something that's similar to ash. This is extremely close, at about 0.1 astronomical units away from the star. We then have a larger disk with larger particles up to a distance of about 1 astronomical units. We then have the outer disk that goes all the way to 133 AU away from the center and seems to have a very strange toroidal shape and a very sharp edge, with all of this also inclined by about 24 degrees. Sometimes the scientists refer to it as the Fomalhaut Kuiper belt. But more strangely, and recently confirmed by the James Webb, are these unusual dusty structures that seem to be extremely complex compared to the Kuiper belt or the asteroid belt in the solar system. While at the same time it also discovered the inner belt that's never been seen before. And the assumption here is that a lot of this was most likely formed as a result of very massive collisions by potentially really large protoplanetary bodies. So kind of similar to how we expect asteroid collisions, but in this case potentially on much larger scale and involving something absolutely enormous, with one of these possibly visible back in 2008 and disappearing in 2014. So this event right here was probably one of these collisions. But the question then becomes, where are the planets though? With the other question obviously being, why exactly is this so complex and so different from the solar system or from many other disks we've seen so far? Why is there such an unusual dust cloud? Why are there so many unusual misaligned disks? And what's causing all of this extreme activity? So there's potentially a lot of collisions here and a lot of destruction, but it's not clear where the planets are. But because these disks are misaligned, there's a chance that there are planets hiding somewhere inside. We just can't see them yet. Nevertheless, even compared to the solar system, this is really extreme. For example, the asteroid belt in the solar system stretches for about 1.5 astronomical units, whereas in Fomalhaut, it stretches for about 73 AU, up to about 80 AU away from the star. and that's about 10 times larger than predicted or expected. On top of this, it seems to have another intermediate asteroid belt between the inner and outer disks, but this one with a tilt of 23 degrees. Currently this tilt is unexplained, but most likely caused by something really massive in orbit around the star. At the same time, the scientists recently discovered another one of these unusual huge debris clouds that previously was mistaken for a planet, and this one seems to be 10 times bigger compared to the one from back in 2004. Which obviously suggests that these collisions, or whatever is happening here, seems to be kind of common. What exactly is happening here, only time will tell. More studies, more investigations, more observations with the James Webb. But these unusual, strange disks, and even unexplained disks, are probably really common. Here's actually another one from a different study that was just released. An unusual disk that surprised the scientists when they realized it seems to produce unusual shadows in various rings around the system. Now this one is a little bit farther away, it's about 200 light years away from us, but even at this distance, the scientists are able to observe various effects happening on the surface of the disk. And here we actually basically just got lucky, because it's sort of facing us, so we can see everything really well. And so at first it doesn't look too strange or too unusual, and potentially contains 2 different planets based on the observations of gaps, maybe even 3. But what surprised the scientists were these shadows that started to appear back in 2015 and 2016. And it wasn't really clear at first what's happening here, until the scientists modeled this and realized it probably resembles something like this. There is some kind of a gravitational interaction between these disks and possible planetary objects that are warping these disks so much that they end up having inclination and produce shadows on each other's surfaces. But if that's the case, and if all of this is caused by planets, it's sort of unclear right now why these planets are in such unusual inclinations, and why they seem to orbit in a very different way from everything else in the star system. And currently the scientists think that there's maybe some kind of a Jupiter-like planet orbiting every 15 years, possibly responsible for at least some of these formations. But why this unusual planet has these effects, or how it came to be, is currently unknown. Although this is not the first time the scientists have seen unusual shadows or unusual misaligned disks, but it's definitely one of the strangest ones out there. There's an older video on the channel somewhere in the description that talks about another one that seemed to have several disks with completely different inclination. So it does seem to be sort of common. So they do seem to exist out there. It's just uncertain why. It's extremely unlikely that anything like this happened in a solar system. And so exactly what makes this unusual star, TW Hydra, so unusual is not really a question we can answer just yet. But studying these disks and understanding how these planets form is super important in order to understand how terrestrial planets form and how one day some of these stars could produce planets like Earth. But until future discoveries, especially the ones from the James Webb that can generally see these disks really well, that's pretty much all I wanted to mention. Check out all of the relevant links in the description below, and also some additional videos about this topic as well. Thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, and maybe support this channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.